should've known that you want me now. Send me your love, but I don't know how to get to you. Can you show me tonight? Show me tonight. Can you show me tonight? Show me tonight. Can you show me tonight? Can you show me tonight? Show me tonight. Can you show me tonight?
Sorry, I can't connect the phone right now, but leave a message and I won't call you back.
Good morning, good morning. Everybody, please, I'm inviting you all, if you like, to the main stage, because we are about to start. As I've told you yesterday, I promised you a great day today, this morning especially, the first half. We are having a very interesting session about research and innovation with special guests. So please approach the stage, because I'm going to invite close to me the speakers, and I have the great pleasure to present you Lauren Vassey and Kunaljit Chadha. I hope I spelled it well. Please come on stage close to me. They are belonging to a research group at ETH Zurich, an institute which doesn't need more presentations. Hybrid timber earth structures. Fantastic. I'm sure that it's going to be very interesting. Everything works, and we can start. Go ahead.
We just wait for our slides, I guess.
Right.
Oops. Go back. Yeah.
Okay. Timer is here.
Yes. Yeah. Perfect. Good. Hello, everyone. Thank you so much for this invitation and inviting us here to present what we have been doing for the past 4 years. My name is Dr. Kunaljit Chadha. I'm the co-founder and COO of Impact Build, and I'm here with...
Yeah, I'm Lauren Vassey, and I'm the CEO of Impact Build, and we are based currently in Zurich. And we co-founded a company which is called Impact Build, and it's based on 5 years of background research at ETH Zurich. So before we jump into our spin-off, I'm going to maybe say a few words about the motivations behind the research project. So Earth-based manufacturing is a promise for a sustainable future. But the issue is we have methods like rammed earth, and those methods are very, very labor-intensive and very slow. This makes them very expensive. So about 5 years ago, we had a vision for a new type of additive manufacturing, which we called impact printing. And the goal was to really push the boundaries in terms of efficiency, but also in terms of scale. So here you can see that the underlying research project and all the partners involved. So here you can see the problem. The problem is that solutions like rammed earth construction are too time-intensive and therefore too expensive, whereas methods like 3D printing are actually not sustainable the way that they're done now, because 3D printing is relying on, let's say, chemical acceleration, and it's very difficult to take it from concrete to other earth-based or natural materials because they don't have this kind of chemical acceleration from, let's say, the process of hydration. So the mission, our goal was to basically make a new industrialized process that would be full-scale and implemented directly on the building site. So here you can see a visualization that we did early in the project using an autonomous excavator, which was developed by one of our research partners. So to make a process that would really be able to be pushed into industry, there's a lot of different benchmarks. So not only did we want to minimize the number of manual steps, we also wanted to make the process very efficient, so looking at how fast we could build, looking at the amount of formwork dependency, because formwork can be a huge cost, especially with different types of concrete construction. And we also wanted to make sure we kept a low embodied CO2. So actually, sometimes when you add a lot of additives, even with sustainable materials, you can end up having a very high embodied CO2. So this is the custom tool that we developed, and it's called impact printing, and it's shooting the material at a very high velocity. And when you shoot at that velocity, basically you get a bonding between the parts, and we're not relying on any sort of chemical acceleration to increase the, let's say, green strength of the material. So when you cut into our prototypes, actually they're fully bonded and that you can't see any joints. When Kunal and I built this structure, this is when we knew that it had huge, let's say, economic potential, because we built to a height with a very slender structure. We built nearly to a height of 2 meters without any chemical acceleration. And of course, with 3D printing, actually, you need to add a lot of additives, and you also have to pause because the material goes from liquid to solid. So we developed also the process so that we could transfer it from an off-site prefabrication where we would build our components in a factory or a lab. And then we built the whole hardware and the software stack so that we could also mount our hardware on an autonomous excavator.
Yeah, maybe I could take it here. And so with every new technique, every new technology, there comes a new set of rules. So when you design with impact printing, we developed the software and hardware toolkit. And to explore that, we floated this topic of using impact printing in a studio project at Masters of Advanced Studies at ETH Zurich, where the focus topic was to create embedded openings in impact printed structures. Now, the students were introduced to our fabrication setup, which basically comprises of 3 units. It has a hopper, a portioning mechanism, and a shooting mechanism. So we can deposit the material, we mix it, put it in the shooting mechanism, it extrudes. It makes sure that there is always the same mass of bricks which gets fed into the accelerator, and then it gets deposited at velocities from 9 to 12 meters per second. This big and this heavy assembly is then lifted by 2 gantry systems which are synchronously programmed at extremely high frequencies. So this can be used as a big 3D printer in Cartesian space. Now, in addition to the hardware, the students were also introduced to a material which is extremely low cost and low impact. It basically comprises everything that can be found from Earth. For this particular exercise, we used material which was an off-cut material from a construction company, which basically means there is sludge, and then we could top it up with other, let's say, earth-based materials such as kaolinite and sand, so we can enhance the cohesive and adhesive properties for the process. Now, a software toolkit was also provided, which basically broke down intended geometries into impact printable trajectories. And also the software could give quantitative insights of production, such as how much weight, how much material, how much time would each production sequence take. Now, the main goal while designing, or let's say one of the main challenges while designing with impact printing structures is to create an, let's say, consistent overlap. Because it's a non-contact deposition process, that means you're not close to the geometry, and you deposit from a distance. And it's somehow like brick masonry, but with softer brick. So having a volumetric, a stable volumetric buildup is a challenge. Here, what you see on the screen is the part in 3 phases. So on the left is the part that you see when it's extruded. In the middle is the part when it's accelerated. And on the 3rd phase, when it's shot and it leaves an elliptical footprint. Now, the current state of the art, or the, let's say, the fabrication setup, the part is elliptical and it cannot be oriented. So maintaining a consistent overlap over curvilinear trajectories is generally a challenge. So this was handled computationally by designing iterative methods where parts were divided over a let's say over a trajectory, and then iteratively spaced out to have a consistent overlayer. Now, this is much easier to do it on one, let's say, trajectory, but imagine doing this for thousands of parts and having consistent volume in X, Y, and Z becomes a problem. So we try to do this over, let's say, a cantilevering structure, which is a column prototype, and then you see on the left when the parts are not overlapped consistently, and in the middle once they have the right overlapping areas. And this led to this column and wall prototype, which is called a volume typology, with a wooden element roofed on the top to enhance and show the volumetric buildup. Now, in contrast to 3D printing or layer-based additive manufacturing, we can deposit from a material. We can deposit the material from a distance, But and we've actually successfully deposited material from 20 centimeters to 2 meters away. But this opens a huge opportunity that we can integrate new subsystems and we can shoot on top of it to build more structures. However, there are some challenges related to stability. So we, let's say, designed computation methods which can change sequences, have non-planar sequences, so that we can digitally guide these elements into the structure, have a fresh layer deposited just before the integration of the elements, and then change the sequencing so that it can always stabilize with the shooting process. Now, here is the result from having a diamond-shaped opening in this impact-printed volume. Sorry. And yeah, we developed a lot of hardware and software toolkit to be able to enable these kind of structures to be manufactured with the same, let's say, manufacturing setup without any additional cost. And yeah, I think these were one-story structures that we created almost 2 years ago, and since then we've been improving a lot in terms of quality, efficiency, and robustness of the process. And as means to commercialization, we were also looking into how can we handle this extremely high texture into something that can cater to a broader audience. So we looked into more formative techniques. So once we deposit the material, it stays workable for an extremely long period of time. So you can push the material back and have a texture which is not completely flat or not completely textured, but something in the middle. So this is, let's say, one of the first tests that we did in the lab, and then we scaled it up ever since.
So what Kunal showed was a kind of formative process, but we also investigated different additive processes. So for example, we also developed robotic surface finishing methods. Here you can see a geometry acquisition, a scanning process that scans the surface that we've previously printed. And then here we're applying a kind of clay-based plaster to the surface. But this gives us a lot of freedom to basically achieve a flat surface, increase the durability, or increase the water resistance through a different type of surface treatment. So as I mentioned at the very start, the whole motivation was to develop a kind of additive manufacturing process that would transfer from off-site to on-site. So here we actually showed that we could put our custom tool and integrate it on a Menzimuk autonomous excavator, which was developed by the Robotic Systems Lab. And we basically built a whole cage, and we basically showed that we can move the autonomous excavator along trajectories and then print very accurately in an exterior on-site construction space. And this is actually a huge deal because these type of machines are actually not very accurate. They're hydraulic. They're very different than the very high stiffness robots that you see in the kind of factory environment. And we actually need less accuracy than you would need with 3D printing because we don't have a tight control between the speed of the robot and the speed of the extruder of the material system. So this was the underlying research project, and Kunal and I have been working the last 2 years on commercializing the additive manufacturing method. We have huge potential to be fast and cheap because we're combining very low-cost materials that can be sourced globally with a very fast additive manufacturing process. So our goal is to dramatically decrease costs, especially benchmarked against the leading sustainable products, and to basically drive impact-driven profitability at a huge scale on a global scale. So our spinoff is called Impact Build, and our mission is to decarbonize construction with robotic manufacturing. And of course, we're reacting to this problem, which is the fact that the building sector is responsible for 37% of global greenhouse gas emissions, and 20% are coming just from new construction alone. At the same time, we're facing huge labor shortages, and we haven't been embracing productivity with the same kind of acceleration that other fields like manufacturing have been embracing, automation and digitalization. So the main problem is that eco-friendly materials are too expensive, or they're supply constrained. So we have timber prefabrication on the one hand side, but timber is really, really in demand by many different industries, and it's supply constrained. And so even optimistically, timber can only meet the demand for 25% of new construction that we need to build. Rammed earth and poured earth, like we were discussing earlier, is just not economically viable. It's more expensive than concrete. It's more expensive than brick and mortar construction. And so we have to reduce costs. And at the same time, from an automation perspective, we're automating materials that are really not sustainable. So our solution is to industrialize our process. And there we have huge benefits because the material is very robust from a supply chain perspective. We're using materials that can be sourced locally. So they're mostly our mixed designs are mostly composed of, let's say, excavated materials from construction companies. We can use different stabilizers, but the mixed design is completely cement-free. And we can increase the kind of durability of the structures by applying these kind of secondary surface treatments. So now Kunal is going to introduce the products that we've been developing.
Yeah, so as the first market entry point, we are looking into making hybrid timber and earth walls. And of course, it has a lot of benefits because we somehow enhance local supply chain, so you can really reduce, let's say, greenhouse gas emissions related to transport. Of course, the material also has low embodied energy. In addition, it's practically impossible to burn this material because it vitrifies. It has great acoustic absorption, especially for medium and high frequencies. And it has a high thermal lag. That means it can retain heat and dissipate it very slowly, which makes it great for passive design solutions. So here is one of the walls that we built without any supports, 2 meters tall, to be able to make these details, so we can make it compatible with timber frame. And the timber frame actually acts very synergetically because then it can enable modularity and also transportation of these prototypes from close-to-site manufacturing to on-site in-situ installation. Now for the local market, we are acting as a subcontractor where we sell in a B2B format customized walls to architects and prefab companies, where we can we can increase the profit margins dramatically by reducing the cost of material and enhancing the efficiency. And for global scalability, we are planning to make our deployable factory to be able to be asset light and be set up very close to manufacturing, close to site manufacturing. And with all the efficiency, the plan is to have an extremely low timeline for return on investment. Now, of course, earth is available everywhere. That's why it becomes globally a local solution. So here you can see a Fachwerk-inspired prototype that, or let's say visualization that we developed, and we are trying to implement it in Switzerland, where you can use the materials with different textures, modular connections, and in a very urban context. And we want to enhance to be able to use these products also in the interior because it's also a very good hygrothermic regulator. That means it can also absorb moisture at a very slow rate, and hence it can increase the indoor air quality. And this image is particularly quite new. It's literally from this week. We are also trying to look at different products. So we are looking at timber earth hybrid slabs where we can make smaller sections which can be integrated together with timber and have them installed post-construction. And
Yep. So yeah, we've been working on the startup the last year and a half. We've incorporated already this year. So we've been pretty successful at fundraising, but we aim to do a bigger VC round. So we're very happy to hear feedback from the, let's say, architecture AEC industry experts. So please come and talk to us. We're also in the process of doing pilots, both in Europe but also in India. And we're very happy also to touch base and initiate other pilot projects. And of course, our motivation is basically to solve the climate crisis, or to, let's say, make an impact by really replacing these CO2 intensive materials. So specifically, we're looking to replace brick and mortar construction, especially when you use very fired bricks that have very, let's say, energy intensive CO2 production methods, but also cement intensive mortar. So we're trying to basically replace brick and mortar construction at scale, especially in low to mid-rise structures. So our aim is to have 350 printing units in use in the next decade. So please come and talk to us. We're happy to hear your feedback. We're happy to get any discussions about the process, about the mechanical properties. And yeah, thank you very much, and thank you for the invitation.
Thank you. Please have a seat beside me. We are trying to have a discussion a little bit later on after all presentations. So please allow me now to continue after this very interesting technology, which gave me a lot of ideas, but we'll talk later. Fabio Amicarelli. Okay, you're here. He's CEO and founder of Foldcast, yes, coming from Switzerland.
Yes.
And he's fighting with concrete,
yes,
in his way. Fabio, the floor is yours. We are keen to see you.
Thank you. Okay, so good morning, everybody. My name is Fabio Micarelli. I'm the co-founder of Foldcast, a startup from the Academy of Architecture in Mendrisio, providing sustainable concrete building elements made with innovative paper formwork. So, Concrete is by far the most used and most polluting building material, with the cement industry alone being responsible for 8% of global CO2 emissions. If concrete was a country, it would be the third largest CO2 emitter in the world after China and the USA. So then, why don't we use less concrete for construction? Looking at the past, strategies to use less concrete for structural application have existed for the last 70 years, like this extraordinary example from the Italian post-war architecture. However, as pointed out by Pierluigi Nervi himself, the complex wooden formwork needed for this kind of structures is extremely expensive, and this makes it economically uncompetitive. And today, not much has changed. Wooden formwork and metal and wooden formwork are still accounting for 40 to 60% of the total cost of a concrete structure. So over the last decade, researchers have explored whether digital technologies can improve the way we make formwork for concrete by making them cheaper, more flexible, and sustainable. At Foldcast, we do this in an innovative way. We use paper as material for formwork. Why paper? Because it is a low-cost, fully recyclable, easy-to-source material, and when folded, it has also a surprising structural properties, and also enables incredible design flexibility, as shown by many artists and designers from the past, like Josef Albers or David Hofmann. So we do this by combining software and digital machines for the cutting of paper pieces that are then folded and assembled into a formwork and used for concrete casting. So then, after 24 hours, the formwork can be removed, reused multiple times, or fully recycled, leaving a very nice finishing surface to the final concrete element. This is how it works. So we keep a simple wooden frame, and inside of it we place our paper insert to shape the concrete and optimize the shape of the element. And this can be done both on-site and for off-site casting applications. This is our first application for a structurally optimized slab system named SlabX. So the idea was to align the folding lines of the paper formwork with the structural ribs of the slab. And so that we developed two structural systems, one using parallel ribs and one using crossed ribs. And the system was then tested with a full-scale prototype made in collaboration with Müller-Steiner Group. Sorry, I see. Okay, there is a bit of lag, unfortunately, in the video, but basically the paper formwork could carry a half-a-ton concrete element, and it was reused 2 times to produce 2 identical elements, guaranteeing a very nice finishing surface to the concrete element. So also a follow-up study done on 10 different casting cycles showed that the paper formwork can be reused up to 20 times while guaranteeing the deviations within the Swiss building tolerances. Finally, we evaluated the environmental impact of the system through life cycle assessment. And so we compared standard flat slab made with conventional formwork and standard concrete with our SlabX system. And the result showed a reduction of 25% of CO2 emissions while enabling for high-quality architectural design and also guaranteeing the compliance to the building standards. This is a second application for a precast staircase system named Vertebra. In this case, the concept was to have that each step is a precast element with a cavity underneath, and then these elements are assembled on a supporting beam, and a concrete filler is cast through a small hole at the top surface of the element to ensure the structural bond with the beam. These are some images from the production of the elements, including the placement of the reinforcement, the concrete casting, the demolding, so opening of the formwork, the removal of the paper, and then the final precast elements. The elements were then transported at the construction site. Each of them was around 70 kilos, so it could be manually installed on top of the beam. And they were finally assembled into a prototype consisting of 3 steps and a counterbalancing base. The steps were also structurally tested to verify the compliance with the building standards. And again, we evaluated the environmental impact through life cycle assessment. We compared a standard precast staircase made with wooden formwork and conventional concrete with our vertebra staircase. And the results showed a reduction of 32% of CO2 emissions compared to the standard, basically offering a lightweight and sustainable alternative for staircase applications suitable for new and existing buildings. Here you can see some images of a rendering. So the next challenge was to bring this innovation to the industry and to make it easy to adopt into existing construction processes. And for this, we founded Folcast with the goal of providing sustainable concrete building elements made with our paper formwork technology. We are developing a catalog of semi-custom building products, including solutions for slab, staircases, facade elements, tiles, acoustic barriers, and much more. And for these products, we offer design to installation services, working with architects, engineers, and contractors across all the design and building stages. We are currently in our piloting stage with 2 pilot projects confirmed, one for a concrete slab at ETH Zurich and one for a concrete staircase for an office building in Italy. And both projects are planned to be completed by June of next year. So this is us. You can find me here around. I'll be happy to answer any questions you might have, and also potentially discuss some potential collaborations. So thank you very much for your attention.
Thank you, Flavio. I invite you to have a seat close to us. Really interesting.
Thank you.
You gave me many ideas, but you also gave the answers while I was noting the things. So I'm inviting the next speaker, who is Alessandro De Lendice. Hello, Alessandro. He's a senior researcher at Block Research Group, Institute of Technology and Architecture, also at ETH Zurich. Alessandro, the floor is yours. Unreinforced concrete masonry. That's your topic.
Thank you very much. So good morning, everyone. I'm Alessandro De Lendice, and I will present this presentation called Reinforced Concrete Masonry, indeed. So I'm a senior researcher at ETH Zurich and also COO at Volted, which is a BRG spin-off at ETH. So I will quickly introduce the Block Research Group. So it's the chair of architecture and structure in the Department of Architecture, led by Professor Philip Block. And at BRG, we focus mainly on these topics you see in this slide, like assessment and design of masonry structure, graphic statics, form finding, and computational structural design. So what we try to do, combining all these topics together, is to have full control when we design something, and we do that through geometry and also through forces. So we develop a series of tools which allows us to do that, and in particular to design specific types of structures like funicular structures, like working in pure compression or in pure tension. And we test them, like here you see like the output of the simulation, but then we also build them in scale models to test if everything we do is actually real and working. So you see a tiny video here that shows the system, like this is a compressive shells with a tension ring around. There is some sounds in the... So we demonstrate how they work, but not only with scale models, also with big, let's say, projects. And this maybe is the mostly known one, like the Armadillo Vault from 2016. Here we demonstrated that these tools are actually valid, so they really work in reality. And here we are talking about a shell made out of 399 stone blocks, dry assembled with no connection in between, kept together just because of the right shape. So we worked on different projects. This is another one from 2018 where we use knitted fabric as a formwork and so on. So by using these tools, we kept working on different new technologies, different innovations and so on. This is the ILO roof. It's an office space close to Zurich. And in recent years, we worked more and more towards unreinforced masonry. So that's the title of this presentation, and I will talk about the two latest projects we did about unreinforced masonry using 3D concrete printing. One is the Striatus Bridge in Venice, and then the Phoenix Bridge that was built in Lyon. So what we can do by controlling all, let's say, the structural design process, the form finding, and so on. Well, in the AEC industry, we have like big challenges. I mean, I will not talk much about this slide because everybody knows this number. And we are also, let's say, the number of people is increasing a lot, so we'll be plus 2.1 billion by 2050. So it's quite then natural that we have to change the way we design and build. And the way we do that when we start a new project is always starting from this equation here. So to reduce the global warming potential of whatever design, whatever building we do, we need to work on some quantities there. One would be the material that we add into the construction, the type of material that we are using. So we want to reduce the ECC of the materials in there, and we want to increase the time. So we want to increase the durability of our project. So considering all these aspects, one way to maybe have an impact is to use unreinforced masonry. And when I say unreinforced masonry, it's more on a structural principles point of view. As you see from this slide, I removed the word concrete because unreinforced masonry, as I said, is a principle. It can be applied to different materials, can be with brick, can be with stones, can be with 3D concrete printing, and of course with concrete. But why we use unreinforced masonry to be more sustainable and to have a new way of design, which is actually not new but very old. So in unreinforced masonry, what is very important is the geometry. So we get strength through geometry, and this results in lower stress. It results in using weaker material, so it's possible to use weaker material there. There is also this concept of material effectiveness related to it. So we use the material for the best property of the material itself, like we use stone in compression and reinforced concrete in compression, so without reinforcement inside. It's a circular system, so we can always replace components because it's a discrete system. We can reuse it, we can recycle them. We can make use of digital fabrication, like 3D concrete printing is a good way to do that, because through additive manufacturing, we can easily fabricate the right stereotomy, so the right shape of the blocks that we need for masonry. And through the tools that I showed you earlier, we have full control in the design process. But this is not something new. So this is a castle from my hometown, 1,200. This is a city in southern Italy from where I come from, so even older than the castle you just saw there. And there was this nice article from the Washington Post a few months ago talking about spolia architecture. So this is not something new. So circularity was there since 1,000 years. So if you look around the whole churches and buildings, you can see that all the columns and so on, they are not the same. They were recycled from other buildings that got demolished before that. So following this logic, this structural logic, we worked on some projects, as I introduced you earlier. One of them is the Striatus Bridge. So this is an unreinforced concrete 3D printed pedestrian bridge that was built in Venice in 2021. This was done in collaboration with the Zaadid architects, Allsim and Incremental 3D. So Johannes will present after me. And as I just said like a few seconds ago, from a structural point of view, this system works exactly as the stone bridge that you see on the left side. So this project was a combination of my PhD at the BRG on the masonry structures and the PhD of Shajeh Bushan from Zaadid Architects that worked on the 3D printing aspect. And this project combined together many innovations and also a different way of approaching a construction project. So we built up an entire computational pipeline from design to fabrication, where we were sitting every week together and working on the same JSON file, working on on the same bunch of data and speaking all the same language to let's say, during the design of the project. I will not talk about 3D concrete printing because Johannes will do that. What I wanted to highlight with this slide is that the 3D printed component were actually used as a primary structure. So we didn't cast any concrete inside, no reinforcement and so on. So these are pure unreinforced hollow blocks. And what is also very nice here, that the prints, they have a variable height, so we could actually manage to build this right stereotomy, so the right shape of the blocks in order to work in compression in this, let's say, big arch. These are some pictures of the assembly in Venice. I mean, it's beautiful, but it's always challenging to build there with the boats and then pay attention that everything stays intact. And the assembly process was actually nothing new, like the same as was done like 1,000 years ago with the centering underneath, and then we were starting building from the spine of the bridge. And then we concluded, so we completed the structure, adding all the balustrade elements on the sides. So you can see from the picture on the right that there was nothing in between. There is just a neoprene pad that we introduced there to distribute the forces a little bit better between components. And these are some of the final pictures of the project. So after 6 months, this project was done, and then together with the same partners, we actually decided to do a second version, but this time as a permanent structure, so not just for an exhibition. So, and when we started the process there, we actually started again with the same equation that we saw before. So this time what we wanted to do, so we reduced the single-use material. The single-use material in the previous project was the timber of the waffle, so for the assembly of the bridge. We tried to lower the strength of the concrete, which usually corresponds to lowering the ECC of the material. And we increased the time because this time this is a permanent structure. So what we changed from Striatus to Phoenix? So the goal was to actually reduce the amount of CO2 going from the first to the second version of the bridge. So from a geometrical point of view, the structure is much more shallow. We increased the number of blocks. There are some advantages that maybe Johannes will talk about later, about, let's say, reducing the variable height in the components and so on. We also included the handrail in the structure through these steel elements. Also here, we didn't add any mechanical connection, but we actually used the compression running into the arches there to keep all the elements together. From a structural point of view, we increased the global thickness. It's kind of increasing the solution space for the forces inside. We improved the printing also by having just one thicker layer instead of two layers, one on top of each other. And both structures were actually fully tested according to the norms. So the one in Italy, the one in France, with sandbags, different types of asymmetric loads and distributed loads and so on. So from a formwork point of view, we tried, as I said earlier, to reduce the single-use material. So here we reduced the timber by 50%. So we developed a system with these cassettes, these things that you see on the right side, where we integrated, let's say, commercially available components, like the one from Doka in this case, with some waffle, timber waffle, and then we pre-assembled the components on these cassettes. And then we lift the cassettes on site on top of Doka towers that were placed in the right position along the spine of the bridge. From a material point of view, this image that you see here, it's actually the bridge in Venice, so it's Striatus. So this is a picture during the disassembly of the bridge. So what happens after the Biennale? So we actually disassemble it. We smashed all the components. So these are the components of the bridge. And then the components were actually used as aggregates for the new concrete that was developed for the project in France. So we went from a high-strength concrete, because that was available at the time from Holcim when we built the bridge in Venice, so 90 megapascal with very tiny aggregates inside. We went to a 50 megapascal, still high. So the average stress in the bridge is about 5 megapascal. So if the material allows, we can even go lower. And the aggregates this time were 2 millimeters, and these aggregates came partially from the bridge that we smashed in Venice. I will skip the assembly. This is the assembly of the bridge in Venice, and these are the results. So these are some of the images right after the decentering there. This is before the installation of the balustrade, and these are some of the final pictures. So we keep receiving images from Holcim, so they keep testing the bridge, so different types of load. This is one, this is another one with a lot of people on top. So now it's already 2 years that the project is there, so we keep monitoring to see, let's say, the state and the durability of the material as well. So as a result of this second project, so we were able to reduce the CO2 by 25% between the two. Of course, there is still some room for improvements there. We noticed this during the design, during the process. But what is nice about these two projects, that they actually demonstrated the circularity that is activated and the save of material is activated by using a reinforced masonry structural principles there. So after this project, I want to talk about, let's say, something that is more, maybe something that is closer to industry, which is the Ripman floor system. So this is a research that started many years ago. So you see that is a floor. This version here, it's actually 3D printed with sand. Like but why we focus on floors, on slabs? So if you look at the building industry and you look at the mass inside high-rise building of medium-rise buildings, most of the mass is actually inside floors, so 41% of the structural mass is in the floors. So if we apply the same structural logic to floors as well, we can save actually a lot of material going from a bending system like the one that you see on the left side that needs to be able to take tension and compression to an arch with a cable underneath. So it's something that let us save a lot of steel and a lot of concrete. And if you extend this to 3D, so you have something like this drawing here. So this research was started many years ago. These are some of the pictures of the first test that we conducted at DTH. This is another type of test, so you see like all the researchers from our group on top of it. But in 2023, this research actually became a spin-off. So it's called, surprise, Vaulted as a name of the startup. And this system got, let's say, improved, more, let's say, industrialized, and this is one version of the slab where we can actually see all the numbers that we hit with this system. So 1/3 of concrete, 1/10 of steel, we can reduce the emissions, and this is 100% circular. So at the moment, we have two different systems that we are commercializing. We have the RFS-D, so double span, and we have the RFS-S, the single span. And these are some of the prototypes and demonstrators that we have been building in the last months. This is one of them with 5 components. So there are 4 corners and there is a keystone. So at the moment, we have more or less 30,000 square meters of RFS that are going to be built in the next years in between Switzerland, Belgium, and the UK. The first 2 were built close to Zurich at EMPA in the Nest building. And the next project that will be built are like this car parking in Switzerland. We have a Crea Tower in Zug, so it's an office tower that they already started. The construction site already started, so we will start soon the production of the slab as well. Indeed, we are on site with this one. And then we have this exciting project in the UK, so that we are kind of getting there, but this would be really cool. It's like almost 18,000 square meters in center London. So this system is also quite flexible in terms of systems, so we can integrate the building systems in different positions above or even below the shell. And this slide is showing a little bit like the build-up with all the layers and also the certification, so fire resistance, acoustic, and vibration, all things that we tested on different prototypes recently. So going back to the slide about reinforced masonry, I want to add another material which is Noncrete, and this is the last project I'm going to show you. Noncrete is actually a company in South Africa working with the government there. So they are removing these aliens plants that they have on site that are ruining the territory there, getting too much water. So they are like plants that are not locals. And what they do, they smash these plants and they use them to make concrete. So there is this product which is like a lighter concrete with some also thermal properties there. And with Noncrete, we are actually developing a system with a single span, so the second one I showed you earlier. And currently, they are they are building up a small school in close to Cape Town. So from a structural point of view, it works like this. So it's like an arch with buttresses on the two sides. They built some prototypes with this material. So you see the tiny shell underneath with the filling, and this is like a load test that was done there on site. And I want to conclude with this image, which is exactly what is happening now. They are just assembling these plates right now, and then they will finish this small school in a couple of weeks. Thanks a lot for your attention.
Fantastic. Thank you very much, Alessandro. Please have a seat close to us. And as you mentioned, there or here, wherever you like. As you mentioned, Johannes is going to continue. Let me introduce Johannes Megens, who is the CEO of Incremental 3D from Austria. Johannes, welcome, and the floor is yours.
Thank you. Hello, everybody. It's nice to be here. So I quickly actually want to talk a bit more of the 3D printing aspects and also of the bridges, and then of course also show a little bit of other stuff we did so far. But first of all, okay, I'm CEO of Incremental 3D. So our company was founded in 2017. We are a spin-off company of the University of Innsbruck, and our background is actually architecture, but we got quite early in touch with robotics and digital fabrication stuff. So in 2015, we actually started a 2-year research project on 3D concrete printing. So that's what we are doing, right? We build physical objects layer by layer with cementous materials, and hopefully in future also with other materials as well. We'll come back to this a little bit later. But what we use is basically a two-component mixture, which allows us to build quickly and fast certain geometries. We are placed in Austria, so we are quite local company. Our office is in Innsbruck. Our production facility is actually close to Vienna, so we are also used to kind of work in an environment that's very fluid, and we have an internal network that allows us to also distribute workloads. Back to Stratus. First of all, as Alessandro already mentioned, right, this was a truly collaborative project. So everybody was sitting together from the early beginning. So fabrication was as much a topic as design and the structural requirements. Otherwise, this wouldn't have been possible. And that's actually the success of this project, that it really brings things together that are usually done in a linear kind of way. First design, then structure, and then fabrication. But on our end, it started actually with getting a new batch of material, a material we never worked before with. And as Alessandro said, this was really a high performance off-the-shelf material with about 90 megapascal of compression resistance. But it basically starts with having like a little prototype just to figure out like stiffening schemes and so on, and how we would figure out the path that goes through. And one thing to point out here maybe is already you see like this artifact that comes from the actual printing. This is this kind of vertical seam. This has got kind of a design feature. So it was not like considered as a bug or anything or a problem, but this actually then was enhanced and got a design feature during the production. Also, in this early stage of collaboration, we did, of course, like all our tests to calibrate machine, material, and so on and so forth, just to make sure we really get all the qualities we require to deliver. So, like constant layer width, but also figuring out the limits of the system, right? So for us, it was, for example, very important to figure out, okay, what kind of layer height windows do we have? Because you see like this keystone here. For example, it has non-parallel interfaces, right? So we need to print from one interface to the other. And as you can imagine, since this is non-parallel, we need to figure out the limits in terms of layer height to the max and to the minimum. For example, for these blocks, this was 5 to 12 millimeters, roughly.
The future is here.
Okay, how do we get to one of these paths? So like path generation was the big research. Alessandro already mentioned this was more or less the PhD of Sergi Bouchan, who is head of computational design team at Dita Architects. And for this project, we actually used like signed distance fields, which is a different kind of technique to actually slice geometry into individual layers. So this goes back actually to the collaboration we had for a long time with Sergi together. So while we actually were doing our research on concrete printing at the University of Innsbruck, we also had joint publications on these slicing techniques, and this is actually also the connection that brought everything together. So this is basically the same principle as before, right? So just for one of these pentagonal deck blocks, the interesting thing here is that there is one more interface, which basically means that we also need to interpolate between all these interfaces, right? So that's why we get these layers with the kinks in there. But what you can also see is like this slicing technique allows to add geometric features in the print path that are not necessarily in the geometry itself. So it allows to generate paths that are actually based on more functional ideas than on geometric described ideas. At the end of the day, we try to have like continuous paths that actually describe the geometry of these objects, right? So, and this more or less just means that we have like many points in space and some additional information like the normal of the slicing planes and also like the section of each layer, because we need to know that how much volume of material we need to point at each position of the path. This gets transformed to the robot. All this kind of procedure, the slicing procedure, preparing the G-code and so on, this can be really nicely automized, so it goes really within minutes actually to generate one of these paths. Here important, you see like the blue and the red areas. So in these red areas, we managed to add less material by just moving faster with the robot. We use this industrial robot, so we can program each target with a speed, specific speed. Higher speeds is less volume, and slower speeds move faster. And then just quickly, basically, we have prepared everything to print the block, right? You just need like a print system. In our case, we use an industrial robot, off-the-shelf industrial robot with some customizations on it. Very important, we use a 2K material system, which means that we have a low viscosity mortar, and at the extruder there is actively mixed in a stiffening agent. And of course, like mixing units, bump units, and so on and so forth, and also like a control system. But afterwards, you can basically start, so mixing like the material, getting ready, and then more or less press play. This is like all real-time speed in this case. You see like this high-performance material, which is super fine, something that we normally do not work with. So there is the grain size of just 0.7 millimeters. And it has a capacity of 90 megapascals. So layer by layer, this builds slowly up. After approximately 1.5 hours, like this block is then finished. Afterwards, of course, moistured and covered to protect water evaporation. But if you do this like 53 times, then you get like a stack of blocks in your facility, and you can get ready to make some more assembly tests or like handling tests more, right? This was also part of the collaboration, so we tested how to move these things around before we sent them to Venice, but you already saw these images. And already just pointed out, right, this seam feature, where like these paths goes in and out. This is articulated on the deck blocks on the side below, right? So they become part of the articulation of these blocks, part of the articulation of the force flow, actually. I will skip these. So just a few details maybe. This was one of the more challenging prints, and you might see why. It has a lot of curvature. At the same time, it's super delicate in terms of its layer dimensions and so on and so forth. Still, it has a weight of over 500 kilos roughly, and it took over 2 hours to print actually. We had to move quite slow to really manage a stable outcome. And overall, it took us 84 hours to actually print all these blocks, right? So it's 2 weeks more or less of printing with one system. What's interesting in comparison to the Project Phoenix is like the total path length, for example, here was 60 kilometers. As Alessandro already pointed out, like the whole bridge got recycled for Phoenix. It was with the recycled material that it was able to drop the CO2 footprint of purely the mix by 40%. With all the design adjustments, the thicker layers and so on and so forth, it got also more effective to print with. And what also was special with this project, we used local sand. So what we received from our mortar or concrete client, partner company Holcim, was actually a premix, and we added local sand that is harvested just 7 kilometers from our facility. So this was also part of reducing the CO2 footprint. I mean, there are still many more levers to actually better the results there, but it was an important step forward. You see, like all these blocks have smaller curvature or less curvature than like the blocks in Phoenix through the fact that it's shallower, but also that the blocks are smaller. In terms of printing, this made a lot of sense because like every print is a 100% guarantee that it works. With Stratus, we had to print a couple of blocks like 2 or 3 times, to be honest. Just because like we did it the first time, it was a new material, and a few curvatures were really kind of at the edge. What's quite striking to me, if we talk about like the CO2 thing here, like the footprint, the blocks with this bridge are just making up for 27% of the total footprint. If you look at the foundation, the steel balustrade, and the neoprene joints. So there are many more levers to look at to actually even better the next bridge project. Okay, I just quickly want to take you through a few other projects we did, just so you can get an idea of what's possible with 3D concrete printing. I mean, this is our first exhibition object. We did 2016 actually. But what we were thinking about is like to have like a porous kind of wall elements, right? So something you would not do with concrete normally. Maybe you know it from an architect like Carlos Galpa or something, but that's not the usual thing to do. And yeah, throughout the years we scaled things up a little bit. Of course, we also worked with construction companies, at the same time working with designers just to refine our tooling and material quality. And of course also getting exposed to earth So this is like retention wall system that we actually did in 2020, survived many winters as well, so longevity is working. This is like for a fashion store in Berlin. Also for Holcim, we did a little pavilion in Basel. Where it was quite interesting because we used the 3D concrete actually as a lost firmwork and the integrated firmwork at this project. And also TV studio. This is interesting. This is like a sanitary cabin, sanitary unit, which was printed on site in one go. A shared office space in Belgium with phone booths. Also, this is an office with this bulged kind of wall elements, which for special kind of purpose units like meeting room or like also a Zoom or like virtual phone booth. And also like what we do a lot is like this furniture stuff. This is in Croatia. Just to sum up a few things, we have materials generally between 35 and 80 megapascals, which we work with. Most of our projects don't have any reinforcement, and especially not the bridges, so they are totally unreinforced, but we do have the possibility to have like continuous steel wire reinforcement, also fiber reinforcement. And of course, with like the programming of like print paths and so on and so forth, we are also able to generate different textures, add colors, color gradients, and like the most beneficial thing here is like for this this column, for example, was done within 1.5 hours, so it's really fast and precise, right? We can be very specific in where we put our material, so that's why we can place this stiffening pattern as we want it. And we get all the geometry for free, so there is no formwork needed, right? And we can be very individual. So if you think of masonry, like every block can have like its structural perfect geometry more or less, and it doesn't matter for us whether like each block is individualized or we have to print like 20 of the same blocks. So the effort stays the same. And of course, like the articulation thing. So there's a lot of potential in just thinking about how we actually use it. I still want to finish with this one. So we only had bridges with 5 footings so far. So we hope actually to also have a bridge with 2 footings in the future. So this is something where we are looking to find some more people that actually engage with us, because like infrastructure and this kind of project already proved that 3D concrete printing can be very effective. Okay, thanks.
Thank you very much, Johannes. Please take one of these chairs close to us. Before passing to the next presentation, please allow me to tell you that there is a movie of half an hour delivered at the Architectural Library Lab, which is at the entrance, coming from Bina. It's a documentary about building in Istanbul. If you are interested, I haven't seen it yet, but I've been told that it's quite an interesting film. But let's continue with our film here. So let me call on stage Stefan Simion, coming from Romania. He's a pre-sales manager from Alu Königstahl, and which is one of our partners in Share. Stefan, I suppose that you are going to present some innovations related to facades. Floor is yours.
Okay. So, I'm Stefan Simion. I'm from Alu Königstahl. I'm from Alu Königstahl, Romania, and we are a part of the group Alu Königstahl, which with headquarters in Wien. And in the next, I'm here to present a short development of the some unitized system facade, which is a key part of this fantastic construction industry. As I said, we are we are the official supplier for the Schuko system in aluminum and PVC, and also the steel system, Janssen system, with solution for fire and architectural buildings, window, facade, and this Janssen is very close to us. It's 30 minutes far away from distance from here. And on the next, I will start to present just a short study case for 3 projects. One is Orchidea Tower in Bucharest, which biggest building, 37,000 square meters with 20,000 facade square meters, which we developed this building with the system. The initial project was developed by an architect office from Wien. It's BHFB, if I'm spelling well. Okay, and the initial concept, it was developed with some idea, and it was taken into an office architect in Romania, architect service, who harmonized the project according to the Romanian and legislation rule from Romania. In this project, we developed a lot of idea. We spent approximately 6 months before the tender, and we developed a lot of solutions, the different configuration. As you see, the final solution, it was in the left side of the screen. And also we developed the image, real image, because the client don't understand really how it looks from a section. Now it's back.
Try to, okay.
Okay, we create image, real image for the general contractor, which was at the first type of this kind of building with element facade. And after, I remember very well, I'm very happy because now I understand how we are doing this building. Okay, the reality of the building is on the left side of the image. We create some movie, that's the idea after the... Can you start the movie, please? We show how we will install the element. Here is not I don't have the image for fabrication, this is only for the installation. And we create this movie, and after this movie, the general contractor said to me, I'm happy, because I have the solution. If it's possible, really more fast. Now, this is the specific installation of the element, and the elevation of the facade requests that the panels are not in the same line, it's decorated. And that means to have some fragments and of installation in some idea. Here, why the unitized system is most important for the construction of the facade is because that you don't lose time, very much lose time for installation. You will have a building very, very fast after all the process of the tendering and the offer is finalized. Next.
Try to point the technical desk. Try to point there. Maybe.
Okay, here is another building. It's a special solution. So where we have more detail. More detail which are created, it's on the base of the construction. This detail was created by Alukenila by us, and it was respected one by installer. This is another construction in Wien, where it's a normal unitized system. It's a unitized system created by normal joinery. And you will see how it is installed into the facade. The utility of this building is for campus for students. That's unusual using of this type of unitize, because usually we are going to using on the office, not in this type of using, for this type of using. And these are some detail created by our colleagues from Alukenixtal Wien and put one-to-one in practice. And there are some references for the system unitize which are tried to recommend and to using in many buildings. And this is the first building created with unitize and with an old system. And I remember very well when I was on the site, when the manager of the site construction told me, wow, I installed 80 square meters in one day. It's unimaginable for a construction facade. This is in 2006. And now what innovation means? Innovation means that all the knowledge before day to day, it's implemented in the future. That means the new system for the unitized facade, ADC 80, represent a total amount of experience before we create in the past. That means we have good efficiency, we have good performance, we have value which are close for the classified for passive house. We have big element available, because on the old time we don't have this type. We have limited at 500 kilo, now we have 1,000 kilo, and the dimension tested, they are 3,000 to 4,000, because when we are out to the limit of the performance tested, we need to test. That it was happening in the project with, I present you first, Orchidea Tower. We tested here in Dorbin at the GBD laboratory, all the tests necessary, impact, wind, air, sound, all. And it's happened that we don't pass all the time on the first test, we cross after the second test. This is a few sections where when we have openable window, it's concealed, and you don't have seen the difference where you have the open element. And also, we have a different visible part of the element from 80 to 107. And we can put also the barrier, integrate balustrade element spandrel, and that's for sunshade protection also. This is the most part advantage of this type of unitized system. And also we have, no? Finished. So, probably it was a movie, but my time is finished. That's.
Try a conclusion.
Yeah. So here it's how we integrate the sunshade. Look. Unitized frame, different type of material, also we have solution in this system. And this is the final image which can obtain with this system. It is more flexible. This is some example for the project, references, and thank you.
Thank you very much, Stefan. I'm giving you my chair. And please allow me to call on stage the next speaker, who's coming from Stuttgart. He's the director of lightweight structures and conceptual design, ILEC. So I just remember Frei Otto, Jürgen Schleich, Werner Sobeck, and now it's Lucio Blandini. Thank you for being with us, and the floor is yours.
Thank you for inviting me, and I hope the presentation is coming. Good. The good thing about closing this panel is that I can just touch base on things that have been said already and just explain that my claim is, in the third generation of research on lightweight systems, to move just from traditional lightweight, the way that Frei Otto was doing, which was a lot about mass reduction, effective systems, into a more sustainable lightweight. I mean, traditional lightweight is sustainable, but I think we have to move further. Circularity, climate neutrality have been already announced, so I don't need to tell that much about that. But I want to stress how important the link to the practice is. I have myself a background of more than 15 years practice, and that was where I developed the research questions that I'm now addressing since around 5 years as the third generation at the ILEC. And just to show you a couple of impressions about the work I was in charge of in the past as facade and structural engineer, here an example how transparent, lightweight cable facade can produce really interesting architecture, in that case for the Ferrari Museum, or also ways we can use the principle of lightweight in a different way in terms of integrating and refurbishing and retrofitting existing historical building. In my opinion, this is also lightweight, because the best way to deal with less resources is just to use what we've been building already and transforming it. So this is an important further development of the concept of lightweight, in my opinion. But also, and there are things in common with the speakers before me, also rethinking ways of using formworks and allowing to get back to such effective systems like shell structures by using digital adaptive formwork system. In that case, we just got 80 formworks, and we produce within 2 years 320,000 square meters of roofing. That is a project of Norman Foster and Partners. So this is just my background in terms of practice, just a selection of it. And now the questions I'm addressing at the moment, still keeping a foot in the practice, but more focusing on research at the moment, is first of all, how adaptive are we? And this is a picture I took from the desert in the US, and I think we don't want to get that far in terms of climate changes, of course, but we want to learn from the nature how we can be more adaptive and more reactive in the way we design and build our architecture. And this is what we try to do with an interdisciplinary research program, which started already more than 8 years ago, and which turned out with a high-rise building as a build demonstrator, which is itself adaptive in terms. Now let me see if the video is running. You can see the tower is moving. Now it's just not because of the sake of making it moving, by the fact that the tower can intelligently react to wind, for instance, we can take out 50% of the steel structures out, because otherwise they have to be very stiff not to move that much. The second thing is that in this high-rise we focus on structures but also on facades, and both structures and facades are the focus of our research work, because they are responsible for a big amount of footprint in architecture. And we are able to engage this tower also with a lot of different facade systems together with industrial partners. So we do fundamental research, but we engage industrial partner and make prototypes out of it. So we have 12 floors. It's a 36-meter high tower. And out of each floor, we can have a different topic per floor, per facade, so that at the end of the day, in 2030, we will have different solutions validated in a real scale. And adaptivity for us means also that we want to show ways and develop methods how transformative architecture could become in the future. So not need to tear buildings down, but just transform them. And we try to use this as a validation tool, because every single component which has been built can be just taken out, re-brought in a circular way into biological or technical systems, and we can enrich it year per year. And what we did as a first exercise to demonstrate that is to take 1-2 floors of the facades out. I mean, the existing facade, what you see, you've been seeing before, it's a temporary facade with a wood timber structure and a membrane. And we made an exercise together with our students, and here we can work with architecture and structural engineering students together, which is something very special. And we were in this discussion yesterday. In the practice, there are a lot of occasions where the two expertises are not really working in an integral way, but are fighting each other. They are bringing different interests, different claims. We try to bring them out to cooperate in an integral way, how to bring to a success of the project. And so here we got students from both disciplines showing how the timber can be reconfigured, how the membrane can be reused as a covering. So there is no single material which is new in this. It's all taken out of the tower. And this is our agenda in terms of skins. We've been starting populating the facade. We are around at the half of it at the moment, or let's say 40%. And also the facades have to be adaptive in terms of reacting in a more dynamic way to weather conditions on one side, but also to user needs on the other side. And so the question is now to rethink the way we design facades, because typically facades are, of course, are a presentation, are the skin of a building, but they're also a way of protecting us from the outside. So outside is the enemy, right? So we have water, we have sun, we have to protect ourselves. Is it really like that? Or if we have a facade which is much more dynamic, suddenly we can engage the environment in a totally different way. So we have foldable systems, for instance, embodied in a ETFA cushion that reacts to solar radiation. We have shading system developed. You can see a sample on my back actually later on, where we can react to the solar radiation. We can react to the need to have glare protections. We have facade made out of textile that can even absorb, like a sponge, rainwater and reuse it in a decentralized way for the building. So we just address two issues. The canalizations are getting more and more overloaded because of the rain, the change in the rain behavior and the rain system. And we can reuse the water. Also, the water is a resource. It's not just something that we have to defend only from. There is a typical architectural claim to not let the water in. But you can let the water in a proper way if you control the way it happens, and it's an additional resource. And beyond that, we do engage our students and their creativity in thinking what adaptivity could become. What's about if our buildings, our architecture is much more dynamic? What about if it reacts in a different way to our needs? what would be then our needs? I mean, these are the kind of questions that we are discussing, and these are some of the outputs. And in certain cases, like here, some of the outputs become reality. So one of the projects that was also touching base on what happened during the pandemic was about contact, was about ways of engaging the buildings in a different way. And here we have what we call magnetic skin, so you can touch the facade, and there is somebody in the inside that is receiving a signal out of it through a magnetic field. I can go, of course, in detail in the discussion, but now it's just to provide an overview. Or we can have facades that are just more dynamic in the way we engage this space in between. So rethinking facades, the way they work as a filter between inside and outside, and question the idea of this filter. So this is one part of our work. Now, I don't need to say that much why we are also working on mineral materials. Most use materials in the building industry, but we have to rethink the way we do that. And again, you can see some of the samples later on done on our desk on my back. So we think about ways how we can reduce the amount of material, similar to the way the colleagues before me are doing, but also in the way we can raise the circularity and we can raise the reuse. And so one of the ideas is to have holospheres, which are completely mineral, which are placed in slab systems and allow us to reduce 30, 40, 50% of the mass. And this is just by using centrifugal forces. And this development is now reached a certain degree of maturity. We made a test in terms of load bearing, in terms of fire. And I will skip this because the time is running. But what I think is more important is the fact that now the very first functionally graded concrete foundation plate is currently in construction. So we have 600 square meters in a real building of the University of Stuttgart, is done within the Excellence Cluster in CDC, where we are able to integrate research topics in a real building with all the normative issues, with all the issues about research transfer into the practice. It is not easy, but it is possible, and it's great that we have the opportunity to develop methods to, in that case, to define how the holospheres can be placed within the building, reacting to different layouts, having holospheres of different diameters, and I believe at the end of the year, we will have the foundation plate already poured, and next year we will have the slab on top of it done poured, and then it will be a perfect demonstration how we can manage to have a transfer from research to practice. In this case, we don't see the empty spaces, the hollow spaces within the slabs. But actually, moving from this experience, the question was, can we make this idea of porosities visible? Can we make it also to a certain architectural feature? And in this case, this is the Marina Ressa coral tree, which has been shown at the Biennale in Venice, actually exactly in the same place where the striatus was before, just 2 years later. And in this case, we didn't print the concrete itself because we've been hearing there are issues about sustainability in doing that in terms of the material. You are very effective in the way you place the material where you need it. Here we printed the formwork. And we printed the formwork out of sand. And we printed in such a way that we didn't even need to waste the sand, but we can reuse the sand. So there is some topology optimization, and here you can see the printing devices. And we just use a biomaterial to binding the sand together, and then we just have a reinforcement only on the top. We pour the concrete, and then you can just wash the sand out and regain it again. I mean, a part of this video is also about bringing that through Venice, but it's similar to the one before, so I'm skipping that. And the next generation is what I would like to show. And this is shown in Vienna at the Technical Museum, done at the material exhibition. And here we show both technologies. So you can see on the one side the holospheres, on the other side the cast, the sand formwork, but they are following the same principle. Circular, efficient structure, which is therefore also much more sustainable than typical mineral structures. So coming now to the end, the question is, what is next? And I was talking already about architecture that has to be more transformative, in my opinion, and I believe facades can play a role, because most of the time our structure of existing architecture is very robust. We have long-lasting structures. The facades are less lasting. I mean, they are typically lasting 25, 30, 40 years. At a certain point, their cycle is coming to the end. And typically, it's a huge issue to take the old facade down, rebring a new one. And actually, I'm questioning why cannot we learn from snakes and have some facade systems and some buildings that change their skins in a way that all the products, the materials is then rebrought back into the natural circles. And so this idea is at the moment further investigate in terms of feasibility. We have a mock-up on the back. So we took a typical German building, but I think it's typical for a lot of European countries out of the 60s, with masonry, with a concrete skeleton, and which has not enough performance. And we brought a ventilated facade out of reclaimed wood. So also here, no need to use further resources, but just reuse materials together with cork as a growing regenerative material, as an insulation material, 3 centimeters, layer by layer, we can bring it, and combining it with aerogel as a high-performance insulation material, so that each of these layers can be rebrought in this circle. So it's in a way, it's like a snake with several skins, one on top of the others, and you can take each one at the end out and rebring them in circle. So this is one aspect in terms of what is next in our way of researching facades. But we're also looking into ways, talking about mineral materials, how we can get rid of cement, because we've been listening, 8% worldwide CO2 production. So it's not enough to say we make structures that are 30, 40, 50% more effective. We still have material and CO2 emissions. So what about if we do mineral structures without cement at all? And we do it with bacteria. So we use bacteria as a way of producing a binding capacity between sand. So it's like a calcinite stone in a way what we produce, but we've been the first research group in the world able to reach 50 megapascal, which is a mid-range concrete, just by engaging bacteria and feeding in a proper way. So we just have to take care of nature in a different way, and nature can help us in our task. This is what we are currently working on. And so I think this coming to an end, this is our way of understanding lightweight in the third generation at the ILEC in Stuttgart. So not just mass reduction, but lightweight in terms of light ecological footprint. And that for us means mass reduction, of course, as well, but climate neutrality and circularity. And of course, this is just not my personal work, but is a work of an interdisciplinary team of architects and engineers that are bringing passion into these topics and helping as a team then produce and developing and generate solutions to bring a contribution to the challenges of our built environment. Thanks.
Well, thank you very much. That was fantastic. Please have a seat with us, and we have some time for discussion. I was waiting for this. Wow, you presented us a lot of the future of construction on this planet, or maybe on other planets. But my first question would be to all of you, of course. How do you see the absorption of new technologies into the construction industry? How fast can we move while we have a mature solution, for example, as you mentioned before, Lucio, how fast we can adopt it and spread it and use it in order to benefit from the performances it has. What's your opinion? And before that, before asking you to answer, and I'm sharing some microphones here, I have one here and one on the other end, and then you can move around. My question, I remember the reinforced concrete, of course, which is the modernity, and it was adapted in a few decades, actually, if we remember, but with a lot of mistakes, with a lot of immaturity in terms of seismic design and other things like this. What do you think about this range of researches? How do you see that? Please, fire at will. Who wants to start?
Maybe I'll start.
Yeah.
I think this question of how do we push it into the building sector is really interesting because there's a tension between incremental innovation and radical innovation. So I think we need radical innovation where we completely rethink buildings and we rethink materials and then rethink also the assembly and construction process from an automation perspective. But we can't implement that already in the building sector. We need to incrementally innovate in order to make a change. So for us, incremental innovation means that we replace something that already exists. So that means replacing, well, rammed earth, even though rammed earth is not used very often, but now it's more about targeting, replacing brick and mortar construction. So I think the path towards being implemented in industry is basically starting with a go-to-market strategy that can be implemented now, but then be thinking big term in terms of innovating across material structures and fabrication methodologies and then assembly.
I would just add to that. I think we are also, especially in our case, we are fighting against perception. And it takes time to come through this perception because, for example, earth construction has been around for so long, but it somehow diminished because let's say the skills kept dying, it became super expensive. But now if you try to industrialize and have it at the same price point, because I think at the moment construction really cares about price point more than anything in the world. And this is one way that we can, let's say, make it as competitive as possible. But I feel that the uptake is very slow. But this is also partially true because it also depends on different regions of the world. Because, for example, in Switzerland, we see earth construction as a sustainable luxury product. Whereas if you go to Asia or India, where I come from, it's seen as something as a poor material, which can be used in vast quantities, but at extremely high scales.
Yeah, but when you speak about perception, don't turn it off. When you speak about perception, you may speak about trust. Trust of users, trust of contractors, of beneficiaries in these new technologies. What's your opinion on that? How can we build trust in new technologies, materials, techniques, and so on?
That's a great question. And first, just to get back to your first question, it's not about how fast can we be, it's more the question of how fast should we be. And we should be much faster than so far the cases. And trust, and then I really link to your second question, is essential. So we do need disruptive technologies, in my opinion, but they have more a long-term strategy. So as research groups, we shouldn't forget to look into the fast future, because we need to have some solutions that in 10 years are mature enough to really make a change. But in the meantime, we do need to work on solutions which just need the last step now. And in my opinion, building demonstrators at a large scale are ways of enforcing this trust. This is the first step. We do need much more of a collaboration between stakeholders from the industry, from the research, but also from the politics. We do have at the moment a new research frame in Germany, which is a new federal research investment, and we are part of it in Stuttgart. And this is really about bringing the different stakeholders together, because this is also my experience from the practice. You really develop trust if you work close together. And I think that is something that we further need to develop, also to raise the speed.
So it's a mixed business, I would say, private, public, business, research, state, enterprises and spin-offs and so on. I totally agree. I was looking at you, and then I'll come back to Alessandro. Yes, please.
No, I will be very brief. I totally agree with what has been said, and maybe just to add, I think it's very important also to speak the same language of the contractors and to really work together and learn from them as a researcher, but also as a startup company in general. Every time you try to bring innovation, we need to understand that these things that we bring has been done already for many years before, and there is a way to do them. And I think it's extremely important to find the less disruptive way to bring this innovation and integrate it in what as it's already the practice. And the only way to do that is to collaborate and to learn and to speak the same language. So at least this is...
So incrementalism and less disruptive.
Yes, exactly.
Yeah.
Yes.
Thank you. Alessandro.
I wanted to add about both topics, like the trust and the absorption from the industry there. I mean, as Lucio said, the trust gets also when you build these big prototypes and so on. And I would say maybe that's not the biggest problem, because indeed, if you do that, if there are, I don't know, engineers demonstrating that what you are doing is fine, you can build test and demonstrator, that's okay. What is the problem is more like the adoption of the technology, and one of the factors are this one indeed, so that this is a very old industry, very difficult to innovate, but also there, politics, indeed, it's a big driver. Sometimes in our experience, some companies, they ask us, can we use your product, because they are obliged to reach certain level of CO2 they cannot do with existing products. So, and this comes from politics that put some boundaries there, then you need to improve and innovate for that. But unfortunately, the biggest driver is still money. And so in that case, it's everything depending from the stakeholder. So you have the stakeholder which has an open mind, that even if maybe it's a little bit more expensive, he wants or he would like to innovate and put something new to the market. But most of the industry is still related to okay, we want to make it cheaper because we get more money out of it afterwards.
I see. I see two ways of acting in this field. Spin-offs, which are trying to develop a singular technology or a range of related technologies and then to implement it to market, and institutes which are researching, which can work together with spin-offs and so on. What is your feeling while developing these technologies on this absorption of new technologies in the market? What is your perception as a continuation of the previous question? Is it happening? Is it accelerating? Where are we today?
Okay, Sherman, may
Go ahead.
I have one idea about how we can join the implemented of the technology, because I think it's on the middle, because on the base of the market and what is happening on the construction. There are construction company and there are workshop factory which are on the own experience. They are on experience and they don't change experience. It's very hard to change something on their mentality. And
especially when you do it well.
Yes, exactly. And the other direction, it's on the top, from the owner and from the architects, which are the main actor, which have capability to implement the new solution and the new technology after they understand very well. And this is our job to make them to have trust in our solution and our technology. That's
Johannes, eventually, do you have anything on this subject? I'm not pushing you, but
No, I'm just from experience. We started the company in 2017, so we engaged with quite some stakeholders. And but I think, like, generally, the problem is really a little bit of a pressure. I think there was already a big of a better kind of motivation to lower the CO2 footprint before, like, I think like 3 years ago, with like all the societal problems we all of a sudden had, right? There was like a Green Deal signed, which was then more or less reduced as well. So there was a pressure coming, and I think this is necessary, especially in the concrete industry, which is a super traditional industry, which almost has, a bit roots, but there's almost no innovation since 100 years. And just a quick example, if there's no pressure assigned to these companies and there's no willing on larger stakeholders and companies, construction companies, you talk to people, you say unreinforced, and they turn around, right? So it's really, I think you need to also pressure construction companies in the sector to really able to introduce something new, because like the pricing is a problem, also new technology is a problem. So there are many levers. They optimized this for the last 100 years, and somehow we need to interrupt this cycle of self-optimization and introduce. And this is complicated. It takes a lot of time. Yeah, it's just a few thoughts.
Yes, go ahead.
If I may add to that, there is also an issue about risk, where the building industry is very reluctant to go certain risks, because of course at the end of the day this is also a money, but also sometimes an existence issue. And so I do believe that the role of the university, I think here we are showing Zurich, Stuttgart and several others play a role, because we have a different freedom to show certain directions and investigate and explore them. The spin-offs are the next level to deal with commercialization, deal with scalability of that, but still in a kind of more product way. And I think we need much more than of that. And then I think we need a frame, and I get back to the political frame. We need a frame where we can develop experimental buildings that works as pilot solutions, where there are eventually ways, and this is what we are trying to do currently, where ways of taking the risk, at least to a certain extent, or reduce the amount of risk that contractors as partners are more able and ready to challenge their capacities and to investigate from their perspective different paths. And then we can really make a difference with the speed that we need.
So it's clearly not enough to research, but to implement research through politics. Well, this is what we mean. What can we learn from the past? And I'm giving you an example, shell structures, concrete shell structures. You mentioned, Fabio, for example, and your work was somehow related with that age. But these structures disappeared at a certain point. I can't say when, in end of 70s or eventually, I don't know. It was maybe 2 or 3 decades of fabulous development of super nice, slim structures which were works of art like you presented, the ones you presented today here, which were produced by 3D printing. But they disappeared like dinosaurs, somehow, in my opinion. Do you have any idea why, or what can we do in order not to walk on the same path and to lose what we got? If you need a microphone, just get it from the...
Go ahead.
Or Fabio, I don't know, I was looking at Lauren.
Okay, I can go ahead. So I do believe that innovation is very much related to also the economic cycles and the broader context that is not only related to architecture and construction, but a bit more in general. And for example, talking about Pierluigi Nervi, structurally optimized concrete structures. There was a moment in history where they made a lot of sense, also from an economics perspective, especially now I'm talking about the Italian context, when concrete was extremely expensive, labor was extremely cheap, so having like complex wooden formwork to save concrete made a lot of sense. And then when the ratio was basically the opposite, when labor became extremely expensive and concrete very cheap, it didn't make any sense. So then the economic drive fell out, and other type of solutions, maybe less optimized and more cheap, easy and fast to build, took over. So I think maybe coming back to today, what is different today is that we have new technologies that allow to basically bring some type of labor still cheap, or make it, let's say, more flexible using digital technologies, robotics, and so on. And this hopefully brings a new era that we are already experiencing with many innovations and startups, where variation and optimization could become or can become economically, make sense from an economical perspective again. So this is a bit, hopefully, to answer your question.
Yeah, thank you. Lauren.
Yes, I agree with Fabio that it's both about economics and about risk. So on the one hand, you have the inversion of material and labor and how those have played out in terms of changing over time. And on the other hand side, you have the issue of risk in that basically it used to be more feasible to use non-standard materials from a building code perspective and to, let's say, prove that they work and therefore validate them and make it okay. But now if we want to, let's say, use earth materials or use materials that are non-standard and have high variability, it's very difficult. You have building codes that are more conservative, you need to go much higher on the factors of safety, and so materials that are highly standardized are preferred from a risk perspective. And so from a structural engineering perspective, we need new methods that handle risk and handle variation to enable us to go back to the past and use materials that are, let's say, variable but more ecologically sensitive.
Well, I'm thinking at another thing. You mentioned basically two ways of doing things or engaging things. One is the idea of collaboration you mentioned among architects, engineers, different kind of engineers, biologists eventually, or I name it, and so on. The other one, for example, I'm looking to Johannes, which said that he has a background in architecture, he was involved in computation and robotics in the same person. So if I'm looking back, I don't know, to Pierluigi Nervi or to Felix Candela or even to Calatrava, there are persons which were incorporating different qualification in the same mind. Or there are other ways, well, which is giving you a certain advantage in understanding and mixing things. And I'm also mentioning here an artistic type of process, because maybe you would agree with me that an artist is studying materials, some artists, of course. There are a lot of type of artists. They are studying materials, they are engaging with their type of art, and they are getting the best of whatever, stone, steel, glass, mixture of materials, textures, and textiles, or whatever, light. or immaterial materials and so on. So what's the path? What's the right way to do? How can we teach this in universities if we are boxed in different domains? What's your opinion?
I strongly believe that interdisciplinarity is very the key. Also in our research group, most of the people working there, they have a mixed background between architecture and engineering, which is, I think, a really good mix, because then you need to understand both aspects, because a building also involves both worlds, so you need to really mix them together. But in the recent years, we need also to add computation, we need to add digital fabrication, and there is also an aspect related to the past, like related to the previous questions. I worked a lot with reinforced masonry, which is not something new, but actually this got lost a little bit in the last 100 years, because we are working a lot with reinforced concrete, with steel, with timber, and so on. And many times when we talk to structural engineers, for example, when we did the bridges and so on, we found a lot of difficulties in explaining how the structure works, what are, let's say, the main features, such as structural typology and so on, because this knowledge is not there anymore. And we think that this knowledge is quite important to understand and to have another way of building structures.
Yeah, first of all, we definitely need in our universities to break these boxes. This is absolutely essential. We cannot just keep blocking the fields or even focusing on one material or another one. We should be more like a sponge, you know, so it's more like a system which is absorbing from different,
somehow,
yeah, more inclusive in a way. So this is one aspect. And so being able to understand the language, the expertises of others is essential, even if you have a wide formation. I also myself studied both engineering and architecture, so but of course you can focus only on certain things. But if you have a wide field of observation and of interest, then you should be still open to other expertises. So working with biologists, as you were mentioning, we work with mechanical engineers, we work with computer scientists. We do have a certain understanding of certain aspects, which is enough to build bridges. But of course, then we rely also on the capacity of engaging these competences. And so a wide understanding of, an holistic understanding of the problems is one aspect, but then a collaboration network, I think, is still the other one and essential to push innovation.
I think we are a little bit captured prisoners from the market, and on the qualification systems, which works in the market, of course, also of the profit mentality, which is engine of the market, actually. So we need our own engine in research eventually to penetrate the market and to change it somehow. Do you have any ideas on that? How is this possible? I know that I'm asking quite big questions, but we are just sharing ideas.
Maybe very briefly, I think we talk about sustainability from an ecological perspective. I like to talk of sustainability also from an economical perspective, and I do believe that a strong innovation, to be strong and to be sustainable in time, needs also to be profitable and to show that can survive in the market. Otherwise, the
economy is one of the pillars of sustainability.
Yes. Of course. So I think that it needs to be acknowledged and it needs to be included, not the main driver, but included in the criteria and taken in consideration.
So it's about balance in the end. Somehow.
It's a negotiation between many aspects.
Yeah.
I mean, just a few thoughts to this. I mean, I'm also involved at the University of Innsbruck Faculty of Architecture, so I mean, there it's quite a wide field of interest and so on and so forth. And Architecture Chamber in Austria, the local one especially, is not really happy with the masters that finish the studies, because what's the problem? They cannot finish like a traditional construction plan within the time they're supposed to, right? At the same time, I think like university needs to take pride in the interdisciplinary kind of approach and maybe asking more questions than appointing workloads to maximize the floor plan output per day, right? So I think like this is a major part of education, that we really raise questions for the future, and we need to take pride the universities and of course also in all the spin-offs that are emerging from there.
Well, my conclusion would be that we have to innovate how to innovate in a way. So there is also, research is not standing alone. It needs some drivers. But let me ask you, because we still have 2 minutes, 2 more questions. One is about the norms. You mentioned that meeting the norms, you provided examples of studies of testing according to the norms, but I have a strong feeling that norms are challenged also. What do you think about this? Are norms a guarantee, or are norms a barrier, or both? Or how can we deal with norms? Maybe Ilek is much more closer to, or whatever. Any idea?
Yeah. All right. Okay, maybe I can start quickly. So I feel construction typically lives in a paradox where for software, there's a lot of computation tools that have been evolved for the past, 50 years. Mm-hmm. But construction still is done in a very manual way. I think industrialized methods need to be certified. Products need to be certified. For that, I think the norms also need to be modified, and there have to be new norms to look at these new products that come out of special processes which add value, not just in terms of economics, which of course in the long run they do, but they also add value in terms of structural stability, like a lot of physical properties in the construction.
If you have something to say on that.
I can continue very briefly. I do believe that standards and norms are a boundary that allow us to operate within a certain boundary. But then, as every boundary, it can be pushed, and it doesn't mean that it needs to be there all the time, but it needs to be updated. So it needs to be, let's say, it needs to acknowledge what's happening in the industry today, and if there is a reason, include innovation. So it can always be moved up, hopefully.
And this has to happen. And my final question, we all know that if you invent something, if you have a patent, then you can get rich by that. That was the history of, it depends on what you invent. So it is this protection of an invention. What do you think about this vis-a-vis something which is like open source? Could a mentality in this field change the speed of absorption or the spread of new techniques of construction? Of course, with a fair revenue for the persons or institutions or organizations who develop the technology. Is this something you ever thought about?
Like at the BRG, so we develop an entire open source infrastructure, which is now adopted by also other chairs at ETH.
You already did this.
Yeah, we did it's called Compass. It's a computational infrastructure for architecture and engineering. So this is there. It's many people are contributing, many chairs are working on it, and on top of that, then everybody can build their own, let's say, applications, and that could be, let's say, a base for a commercially, let's say, commercial product. So there is a base that has all sort of input from other people, from contributions from institutions and so on. It has been adopted by companies as well. and that is a base for then developing by your own, if you want, like a commercially available plugin, a commercially available product. But there is still like a big open source contribution there, which allows everyone that can just download from the internet the code and so on, and have already like a lot of things related to structural design, computational parametric geometry generation, and so on. So I think there is a lot of development there. Then if you have a specific idea, then you can of course make it in a commercially available thing, I would say.
Thank you, Alessandro. Well, I think we are done. And I thank you very much. I think it was a very inspirational session. I think you all agree on that. We saw the future for some moments, some minutes. Thank you very much for being and sharing this with us. And I'm declaring a coffee break. And big round of applause for you.
You love me, don't let go. If you love me, don't let go.
Hello. I have a request. All jury members are expected to be in the room number 4 in 5 minutes. So please, all the jury members, please come in the room number 4 in the next 5 minutes. Thank you.
Coffee break is over, but you can take your coffees and join us in the amphitheater because we are going to continue. We still have some jobs to do today. And please let me announce you the future. The future is about a very interesting presentation which is going to be delivered by Anja Kranz from NAX, but I will come back to you in 2 minutes. Then we are going to have a presentation which is coming from far away, from Kazakhstan, about the development of Almaty city, which is going to be delivered by a person who's really involved in that, which is Ashhat Hasaduov, and then we'll have a debate. I don't know yet, but I will be inspired in the meantime. How are we going to join the two subjects? But what I will ask you not to forget is that at 10 minutes after 1 o'clock, we have a special guest lecture and conversation with Spencer de Grey, which is senior partner and head of design at Foster & Partners, maybe. And this is going to be the closure of the session. So, coming back to you, Anja, NAX is, and it stands for network, A for architecture, and X. I'll let you present.
Yeah. Hello, can you hear me?
Probably you have to open it.
Oh, sorry.
Or not, or we have to...
Yeah. Can you hear me now?
Yes.
Yes.
Perfect.
Yeah, hello. Thank you very much for giving us the opportunity of being here. Since Share is a very important network in Europe and far beyond, I take this opportunity to also present you two other networks. First of all, as already mentioned, the NAX, which is the Network for Architecture Exchange, and we are based in Germany, and well, our slogan, so to speak, is promoting architecture made in Germany. But we are going far beyond, and you're going to see why this all could be interesting for you on an international level. If we go to the next slide, you can see our mission already. And to make it very short, we could sum it up in 3 words. It's promoting, supporting, and connecting. Promoting means we, the Network for Architecture Exchange, we promote architecture made in Germany, in politics and business on a national level, but also internationally, and planning services. We support German architects when they try to reach new markets, when they go abroad, but also investors that are looking for German planners. So we try to connect them and to support in connecting. And of course, the connecting part is also the one when we say we try to get together export-oriented planners with local international colleagues. And I forgot one very important thing at the very beginning. The NAX, the Network for Architecture Exchange, was established already 23 years ago, and we are an initiative of the Federal Chamber of German Architects, which is that chamber for architects in Germany, and it englobes 140,000 architects that are registered within their regional chambers, and by that within our BAK, Bundesarchitektenkammer in German, the Federal Chamber of German Architects. Our mission, I've already mentioned some of the points here. We are supporting, but we are also representing our architects, our network, which I'm going to present a bit later. Of course, our target group later on, I'll present in more details, but our services, yes, we are positioning the German planning, but we are also the door opener, because collaboration goes in 2 ways. And that means if we want to work internationally, of course, we open the doors on 2 sides, not only for our architects going abroad, but also for our other architects wanting to reach out to German architects and getting in touch. We do a lot of knowledge transfer. Also, I'll give you some examples on that later on. Our strategy, I had mentioned that also already in some words, but now some other words on this. We could say it's cooperation, participation, and also communication. Cooperation, we see how we can do that, maybe together on an international range as well, not only nationally. Participation, we also try to place our architects as lecturers, for example, but also try to get, of course, international knowledge in, because, as we said, collaboration only works together. Our activities and events are one of our most important parts of our work, of course. So we have a lot of cooperation and networking events, such as delegation trips and market exploration trips. Some of them we do ourselves, other with ministries. We have training and information programs. And we do not only communicate and within our network to also put the network with itself together, but also, of course, once again, internationally and abroad. Policy work and dialogue is also part of our mission. I'll show you later. Once again, the slogan, I think it's important to point this out one more time. Architecture made in Germany. Our network is German architects, but if we go abroad, it's only international that it can be done, and vice versa. You have to know the markets. When you come to Germany, you have to know the market as well, and it's always good to know whom to contact as a contact architect networks. I'll come to that once again also later. Here's a selection, because I mentioned who are our members, our target group. So these are the NAX members. We have a network of, this is only a selection. Altogether, it's 65 offices in Germany of different ranges. That means some of them are really big and very established. Some of them are newcomers, emerging offices, so to speak. All of them are important for us because all of them can give different insights for a knowledge exchange and also collaborate together and bringing in new ideas. Secondly, our partners. That means we also, of course, connect the network to industry partners. Here you see the selection of the ones who are our current partners from different fields. There are main partners and project partners. At the present time, we have 6. And I mentioned the politics level also as well. So, for example, we work with the Ministry for Economics and Energy. It's called the Foreign Office, of course, and some more. Our industrial chambers of commerce, Germany Trade and Invest, but also on an international level with UEA or ACE. to name some of them. You can read a bit more about it, and I'm happy to answer questions afterwards, of course, on our website. What do we do in concrete? I mentioned our events. Where can you find us? Where can you get in touch with us? We are every year at the MIPIM in Cannes with a booth where we connect the built environment, so to speak. It's not only NACS members, it's way more open because it's funded by a ministry. We do the delegation trips. I'll show you some of the photos later on because images may say a bit more than just my words. And we do an experience exchange regularly in the DACH region, so Austria, Switzerland, and Germany. This is also with different architects from these countries, but it's, for example, we had post-fossil competitions as a core topic this year, where we put the experts together. So it's important to know, we as the network, what we do is putting the experts together and to sharing their expertise. So that's really our main core competence, what we do in our everyday life. Other important meetings, as I mentioned, we work also regionally, nationally, and internationally, and some of the examples you see here are also on a national level. We have an annual member meeting every year that's in Berlin, and that's 65 officers, some people from politics, and we put this on a specific topic every year. It could be sustainability as a topic, it could be also have a country focus, and so on. So that's how we do that. And on a regional level, we do that as well, so that people can gather more easily. We go to the UAA Congress, to fairs. We have so-called fireside chats at the end of the year where people come together one more time and to see what we did. Speaking of the photos, so to give you just some images, so you could see a regional meeting with site visits we did. We presented our exhibition Now Near Next, because exhibitions are also part of our work, and we have a hybrid one now, or actually an online one, which you will see in a short film later on. And one of the images is also from our annual meetings. Another one you can see, there's fairs, there's the latest UAA Congress from Copenhagen, but there's also MIPIM on there, or also the Biennale di Venezia, where we have a breakfast with architects also to connect. Yeah, and as you can see, we go up road and sometimes we go far. Our last delegation trip from last year was to Saudi Arabia. And this year's trip was to Canada and the United States. Last year's trip was done with a ministry together, so it was highly official, and this year we organized it all ourselves. When I say ourselves, to give you a range of who we are at NACS, we are 4 people, not all working full-time, also part-time. So this is what we put together with a team of 4. I talked about the exhibition before, and I said, like, there are static ones, as we can see them here, and we try to have this online. So we make it hybrid. I have postcards with me. Who is interested of discovering more of this exhibition can do that later on. I brought it with me, but now we have prepared a video, which I would like to show, and I try to discuss a bit more, explain what we did with this exhibition. Yeah, it's very interactive, so it's a bit like the internet itself. You have to imagine, you have different dots. You have a studio range of the participating German architects who are within this exhibition. They show their projects they have done within Germany, but also abroad. It's a bit fast. You can see, you can also reports integrated in this, specific topics, and the dots you have seen at the beginning, they connect it all. So you have the studio range, you also have a glossary, you can search, you have a topic flash, and we hope to make it grow. And it's quite a challenge sometimes. I don't know, some of you have certainly also worked hybrid already. It's always a challenge to connecting the real world with the online. So that's a bit what you can find in a very short 2-minute trailer movie. Yeah, some of it is in German, unfortunately, I have to say, but we also have an English website with the NACS, which we are developing a bit further now, but if you have questions, of course, we are always happy to translate a bit and see what we can do. Yeah, thank you very much. So if you want to take a look at this later on, I have some postcards with a QR code, and you can deep dive into that, or just come to me later on if you have some more questions. I'll go on with the presentation on NUX. I have to see if I can. Yes, I can. I've mentioned some more what we did before about events, our exhibition. What we do, of course, we do have a website. I just mentioned it. And on that, you can find, of course, contacts beyond NUX, because we want to make this as transparent as possible to have you access, not only NUX members, with everyone visiting the website to getting in touch. So we have a country database. I'll get back to that later on, because that's really interesting to connect, and a country database and contact architect database. Of course, we show other points of contact, international organization and networks, and also like how we can give public sector support. We have data on international construction, so we have surveys, we publish them, of course. We talk about the international professional recognition. So what do I need to have to work as an architect abroad or in Germany? So we try to provide this information as well. About finance and insurance, that is important. And of course, our declarations of intent, you can find there online as well. Furthermore, we have reports 4 times a year. They either address a country or a specific topic, and you can just subscribe online, of course, free of charge, and telegrams that we send out. And experience report, everything is linked on our website. Not only if you receive the report, it's easier, of course, so happy if everyone wants to sign up, you can do that. And but everything can be found on the website as well. And we work together with Germany Trade and Invest, and we link to other information portals, to webinars and the exhibition you have just seen. So I don't want to repeat too much. I have a few minutes more to go. As I said, we always look for experts from specific regions. So if you feel like you want to get in touch with us, you can also subscribe in our database. I'll come to that in 1 second. We are happy also to welcome speakers from all over the planet on specific topics. We are also happy to promote events if you have ideas, of course, that we see that are also, of course, interesting for our network. We help to search for architects, we send network information and so on. So that we do quite a lot, and all these information also shows ways to cooperate. I mentioned the country database earlier and the contact architect database, because I mean, now I'm talking about a network of German architects, so what's the interest for you as an audience and architects from all over the globe nearly? So the country database, as I mentioned, and is giving a lot of detailed information on the aspects I mentioned before: finance, insurance, what do I need to work in as an architect, what are legal frameworks, and so on. And we try to keep them up to date, but the information can only be as good as the information we get delivered, of course. And a lot of this information in a first step is only available in the country's languages themselves. So what we need to do as a step is mainly going through English and then translating it into German to providing this information. So if any of you goes to our website and feels like, oh, my country is missing, information is missing, we are more than happy to get in touch and of course, then gathering this information and filling them in so that you have one address to search for information or deep diving. And now the contact architect database, you as an office can sign up. You can show a project, you can show what you have specialized in. And if people, for example, from Germany, but also from abroad, think like, oh, I want to go to this and that country, is there a contact architect I can get in touch with? You can do that via our website. So it's an easy thing. You won't just sign up if you feel like it or take a look at it, and then people can get in touch with you, and you, of course, can get in touch with the other people as well. I'll skip these 2 pages we have, because there's another project I would like to present to you, and that's a European EU project. The reason why I present it is also, it's a platform with really a lot of information, and it is also providing a network which is free of charge, and it's going beyond Europe, and it's growing. So what are the main objectives in this project? It's dealing with It's a European funded project. It's dealing with architectural design competitions in particular. And here you can see some of the project partners. For example, the Croatian Chamber of Architects is a partner, the Slovenian Chamber as well. We have Cyprus on board and also Hungary. And we had cooperation partners. As you can see, Switzerland, of course, is not part of the European Union, but has been a cooperation partner. And we are growing, and we just had some new partners, such as Estonia, Romania, Portugal, and Italy. So why is this important? Well, the main objectives, we try to promoting high-quality architectural solutions for the built environment, and the international exchange should be fostered. How can we easier participate within international design competitions? And we want to make this by providing information one more time, way more accessible for everyone, because you don't know the country's regulations sometimes, which is really hard to know. Sometimes they only exist in their own language. So how would you know where to go to? So this is really a go-to point. We did this by researching, by practical support, and we do also political advocating in this project. And the main outcome of this project is a platform, the ArchE platform, which is free of charge, which will be online beyond the project. I think that's interesting to know. It's not going to end with the project next year. And there you can find reports and mainly online tools. And some of them, I just want to show them to you very quickly because I think they could be interesting for you. Overall, the project is, as I showed already, it's going to politics for a white paper, the research part, online parts. This is how we did it, and the tools. We have a glossary developed for 11 languages now, showing the different rules and guidelines of each country, and you can compare these glossaries. That means when a specific word, even in Germany means that, in Austria it might have a different meaning. You can look this up and compare and trying to better understand. That's the platform, what it looks like. Sorry, this is the glossary. And you can also dive in. I'm happy to give you the email address later on, but you can see it also written at the bottom of the page. The ADC map, you can also do the same thing. You go to a country, you get some information on the country regulations immediately. So in a nutshell, so to speak. Then the network, and this is what I like to present. There is a network opportunity. You as architects, everyone can sign up if you're interested in being part in ADCs. So you can simply say, I'm interested in ADCs, I would like to be a jury member, I'm an organizer, and sign up for free in this network. And once you have signed up, you can get in touch with all the other people within this network. It's a growing network, and it also stays free, it's online. So, and it can go beyond Europe. I think that's important to know. There's an evaluation tools that you can see the different criteria of design competitions. The research, we have the results with us. This is all online in 11 languages. I have one in printed here. It's an RT map on ADCs, which shows the different regulations of the countries, also good practices in each country, but in this case based on design competitions. And I'm nearly done. I'll go to the last slide. The white paper also in a printed version, which we are going to present with some wishes, what we wish for ADCs on a European level. Well, that was quick, I know. I hope you got some information, and I thank you very much for your attention. Thanks.
Thank you. Will you please be so kind to stay 2 more minutes for a short discussion?
Pardon?
Will you please stay a few more minutes for a short discussion? I have some questions for you.
No?
Yes.
I sit down.
Yes, yes. If you agree, thank you very much for your presentation. I think I'm very curious, and if I'm very curious, probably somebody else is very curious too, from the public.
Yeah.
Yeah, and I have a microphone for you. And I have good experiences with NACS.
Oh, that's nice.
Yeah, I can tell you, because I've worked with some German architects in my home country, and we exhibited at one of the UI congresses. It was the one in Turin in 2008. So this is when I met Next, but I also met Next in other events of UIA and also ACE. But my question is, because it's a very interesting structure which involves ministries of the government, of the federal government, local government, offices of architecture, partners, companies, and so on. When was it born? How old is Next?
Sorry.
And what was the initial, let's say, boom which created it?
The reason to create this network was that we realized that even on a regional and national levels, people need to talk, they need to network. And you have all these wonderful experts with all the experience, and if you keep your experience to yourself, it doesn't help others. So the Federal Chamber of German Architects in 2002 decided to create this initiative. We have to say, as NAX, we are partly independent. Of course, we stick to every regulation with the Chamber. We work together conjointly with them. But our focus was on these German offices to saying, like, they have all these great examples. They go abroad. They want to work internationally. So we focus on the international offices, of course, the ones who want to work internationally, that have experience, and we need to connect them. And then it grew. So it started 23 years ago, and it grew constantly. So we are 65 offices now, all different range of sizes. I think that's also important to know. We have big players. You have seen some of the names in there, which you might know internationally also, like, for example, HPP or Graft. But we got newer colleagues as well that can be two-person offices, and they really they are young, they are inspiring, and they also share their experience. So the idea was really to connect, because good architecture, you need partners, you need good and reliable partners. And that was one of the ideas why this was founded and why we still go on.
So the initiator somehow was the BAK. Yeah, the Bundesarchitektenkammer, so the organization of architects, the federal organization, of all over the country. Yes, thank you for this information. And it's financed by everybody involved somehow, or what's the structure?
Well, actually, we are, so to speak, self-financed. So NAX, the initiative, we are, of course, all our members help finance with a little membership fee, and we have our partners from the industry. And that's how we try to make everything possible as far as we can. So
if everybody puts some money, then you're independent. You're not depending on somebody specifically. So that's the concept. Great. And the final question, and probably one of the most difficult, I'm sorry if it's too difficult, how do you measure the efficiency of the results of this network, and you create good perception among the members and the architects?
That's a really tough question, and we get it quite often. It's like, it's something you cannot measure with numbers. We get this, of course, after fairs, how much business did you make after fair, and so on. What we say, for us, it's really, we are, as I said, an accelerator, a connector, maybe how do you call it, a boost, to get in touch. And then we hand it over. So it's the responsibility of our network, of the architects, working together then. What we can't measure it by numbers. What we know, of course, we ask feedback by our members. Did you get business out of this at the end? And what we know is, via us, some of them also on a national level started connecting. They gathered ideas, they got contacts in foreign countries while we did the visits. So as you said, it's a really tough question, and we have to say we cannot measure it in numbers, but the success speaks for us, because we have members that have been with us from the beginning, and the network is growing, and it proves that it's still needed. And we hope to go further up-road, and really we are also happy to, like, if anyone wants to get in touch, I have business cards here, I have some more information with me if you would like to get some, really happy to discuss this a bit further with any of you, anytime, also virtually, online, if you want to.
Thank you very much for all these informations. And I have one final question. Is it replicated in some other countries, or did you inspire some other organization to act in this way? Because this made in Germany looks really, really strong.
In Germany, I would say Jein.
Jein.
Yes, because
Yes and no.
I think we have been inspired as well. We should say in France there's a structure called AFEX, and they are actually doing the same as we do. So it's not a chamber, it's an organization for the export. Because like in German, I think that's also interesting to know. We call it in English, and I think that's the way better term on putting it. We are called Network for Architecture Exchange, because it is an exchange. In German, it's called Netzwerk für Architekturexport, so exporting, which is of course also part of
one
this.
way.
It's one, but that's one way. It's not giving back, or it's not showing what we actually do. And yeah, in France there is one. This is the example that I have in mind, and I have to say we got inspired by them. And I know they have 30 years next year, and we have 24 next year. So we're still working on the 25 in 2 years.
You're quite mature already. Yeah. Thank you very much for that. This was Anja Kranz. Please, some applauses. And thank you for this information. Yes. No, you can. Well, so now please allow me to invite on stage a gentleman coming from far away. It is Ashhat Saduov, who is the General Director of the Research Institute of Almaty. And nice to meet you again. Yes, if you like. And I'm sure that you are going to bring us to Almaty, or vice versa, or both.
So I have 10 minutes, right? Okay. So I come from a city called Almaty, and this is one of the popular images of Almaty, and it's the city next to the beautiful mountains. And if you compare mountains with the city is miserable, and whatever city we build and develop, these mountains will digest. And we depend very much on a central part of Almaty, so that's why my speech is about the polycentric development of Almaty. Here is the historical layers of architecture we have, starting from like ancient era and up to now. And this is like 19th and 20th century buildings, just to give you the understanding of the city. So we started from the Almaty Development Program 2530, and this is the 6 goals we focused on, and the SDGs by United Nations. And we defined the 5 polycenters, the central, the existing one. We're gonna have a little extension of that and develop another 4 polycenters to make city equal for everyone. So this is the master plan structure. It consists of 6 blocks. The first is the main functional drivers of the economy of the city. Then we have a spatial structure and connectivity between them. There's also the activation zone, the opportunity zones. The red framework, it's where we create jobs and public facilities. The fourth is quite new for us, and it's very important. It's called vernacular districts. So we measured the existing vernacular districts, and we somehow trying to create new ones in these new polycenters, because it's day-to-day life and how people and neighborhood associate themselves with this space. The fifth is transformation of the existing morphotypes and creating new morphotypes. And the last one is detailing the growth nodes within the polycenter. So this is the main drivers that we have defined during we were developing the program. Oops, that's no presentation. Yeah, we'll come back to this later. So this is the famous street. You all know the Oxford Street, and there is a rule of 80 and 20. So 80% of all businesses are located on a 20% of most accessible streets. So the city consists of different elements in one system. So depending how we interact these elements and what mixture of these elements we create, the result vary depending on these elements. So whether we do the comfortable and sustainable and healthy city using all these diversity of the elements, or if we focus on just active transport, public transport, and private transport, we create not comfortable, not sustainable, not healthy city. So talking about the elements, the density and centrality is quite important to connect, because this is today's Almaty, and you see the southwestern part of Almaty now is quite dense in terms of living, but the centrality and the density of the streets, it's not there. It means that these people have to move on a daily basis to the central part of Almaty, and the central part of Almaty, it has a high dense of the activity functions, but lower dense of the housing. So in terms of street network and walkability in 15 minutes walking radius, Almaty has quite a good structure to create and retrofit areas to make it more polycentric. And we comparing the future city and today's city, so the idea is to spread out this density all over the city, so to distribute the goods to the citizens. Another different researches we did through accessibility in different scale. So it shows that the polycenters we create, they are connected to the existing center through the density of street network, and we replicate the existing street network and the size of a block to make it more walkable and human-friendly, and replicate it all over the 5 polycenters. That's the idea. And in terms of the street hierarchy, it's very important that the functions are on a right position. So the most accessible streets has to have an active functions, and less accessible could have a sleeping area, what we call. The red structure, it's public and commercial facilities. So this is creating jobs and services next to the neighborhood, so everyone has in 15 minutes walk all set of the services around the neighborhood. So this is the map of vernacular districts, existing and future ones. So we were trying to create this human-sized city, city for people. We worked on the morphology, look at the central part. It has a high diversity and the size of different functions, unlikely to other areas. So having all that, we are trying to make developers take these all things into consideration, change the approach in terms of creating the perimeter blocks and add the red, what we call red facilities, the commercial facilities, public facilities, so to create this diverse city. Also, all this analysis helps us to do the transit-oriented development, to connect all these polycenters with different types of transportation infrastructure, and we divided it into three scales: city scale, district scale, and local scale transportation infrastructure, which evenly distributed all over the city, and it has 3 different scales and types depending on what transportation infrastructure interconnects within these core areas. The what we call fast corridors for the public transportation, we tried to connect from south to north and from west to east to make it more equal. So, and this grid creates the good coverage of fast public transportation, so people can move from one police center to another police center. And yeah, so this is a function programming of one of the police centers, which called Eastern Gate. It's next to the airport, and it has a lot of high streets that connects the city to the region. Our mayor wants to, because of the name is Eastern Gate, our mayor wants to have Eastern architecture. It could be traditional, iconic, gardens, contemporary. Also, we tried to give, for the next stages for architects, we would like to give the hints how they can rethink the existing architecture, existing Almaty language of architecture. And this is how the site looked like. So we have like 2 big green fields on the west and the east. And we are looking forward to bring architects and brief them properly, so we in the end get a better city to live and to visit. So yeah, I think I'm done in 10 minutes.
Right.
And if we go back to this analysis here, so it shows that Almaty overall is closer to Venice. The score shows that it's closer to Venice, but the central part is closer to Barcelona in terms of the street grid. And why it's Venice? Because Venice is divided with canals, and the canal not connected on 2 banks. And this is our highways with these flyovers that breaks the city fabric. So overall score is closer to Venice rather than Barcelona, but the central part still works very good. And our idea is to distribute this a comfortable city evenly all over the city and accommodate the migrations from the region, because we have like 500,000 people on a daily basis coming and migrating to the city.
Great. Thank you very much for this insight, for this interesting capital city.
Yeah.
May I ask you to join us and to sit down and to launch a conversation? I'm calling on stage some more people. Is Burak Bekoglu here? From Bina, from Istanbul? Hey, Burak, where are you? You were about to present a movie an hour ago. And Magdalena Placica? Magdalena, thank you very much. You are from Aluprof, one of our partners. Please have a seat with us. And I'm calling Burak again, once, twice. He's not with us. Okay, so I was instructed by the organizers to have a short debate. We have something like 10 minutes here. The most difficult thing is that I was not instructed on what subject. So I have to invent one.
Okay.
Yeah, all right, and I did one. I'm thinking about what we are doing here, actually, about share architects and this kind of events. As I know, you were part. You're not the first time in such an event. You've been also host in Almaty this
Yeah,
year?
this is my third Share Architect event. So
right, and yes,
the
of course.
first one was in Tashkent.
Tashkent and Almaty. Right, and now in Dornbirn. And are you the first time in?
No, it's the third time. The last time was in Athens.
Athens, last year or 1 year ago with the awards, with the first edition of awards. Okay, so you have an experience, and the other. You're Burak? Okay, nice to meet you. Have a sit.
And the first one was in Serbia.
Serbia. All right, so you have another experience. Let me give you the third microphone. Thank you. All right, thank you. And Burak, I was asking my partners of dialogue if they are familiar with the Share events. Are you familiar? It's the first time you come? Or?
Yeah, I have been quite maybe before the pandemic. I was a guest in Slovenia first time. Thanks to Florin, it was a great experience, and then I've been quite a member of the society.
Oh, excellent, excellent. So we have different experiences.
Yes.
All right. So my topic, my subject is about what do you think and what do you expect from this kind of meetings? How can we improve or transform? Because we are really keen to do that, and maybe you've seen that we are trying a lot of composition, I may say so, a lot of things. We are looking for diversity, and we are experiencing. And some things we abandon, some things we enhance, so it depends on the reactions. So with your experiences, please fire at will.
Okay, if I may. I like presentations, and I think they're very valuable, and they bring a lot of new points of view about architecture, not only architecture, building in this industry, sustainability, and other topics. But I think discussion panels are quite important, because then we can exchange our thoughts in live structure and just in heat.
So are you suggesting a combination of these?
Yeah, a combination of those, and I think it's a very great chance to find mentors for younger architects.
Yeah, mentors
and also,
are really important.
Yeah, but also they can benefit from getting some young architects' energy, that is still very excited about designing, and sometimes older architects lack it because they're burned out and overworked, so they might actually need some of that idealism and young people's energy and optimism, and also different points of view because of the difference in the background that they come from. It's a different generation. They look at life differently, and also architecture, like life-work balance is more important than just working till late hours to achieve something. They don't follow success, so
Yeah,
it's not the most important thing to be successful. Most important thing is to enjoy life now, and I think we could actually
that's the greatest,
benefit.
if you ask me, that's the greatest success.
Yes.
To enjoy life. Yeah, thank you for this opinion. What do you think, Burak?
I think it's already improving itself. It's growing as every time I visit Share event, I meet with new colleagues and friends, and it's also a great opportunity to catch up with new trends, and also meet with colleagues from different cultures, different regions. So it's I think great opportunity to keep updated with possibilities and with global stage where architecture is going. And for that behalf, where I'm from, Istanbul, and last year we had the first Share in Istanbul, and as a local in the city, I was also helping for the organization. So it was also very interesting to have the Share event in Turkey, in Istanbul, first time. So it was a good start, and I think we'll continue for this collaboration as well. For me, I think it's on behalf, aside from the sharing architectural voices from different authors, from different collaborators, it is also making new friends. This is, I think, very good as between us and also learning from each other. So I think it's like become like a school itself in a sense. And also, what would be nice to improve this kind of exposure, where I'm observing, it will be interesting to try to engage maybe communities and also people who are potential users, also decision makers, maybe aside from the architects, can be tried in a multidisciplinary way in some shares maybe. That can be interesting to improve that site as well, because there's already a rich community of architects and colleagues that we are improving, but also it will be interesting to experiment with maybe different disciplines to maybe discuss certain ways of evolving architectural practices and also making impact in society, in maybe in sustainability measures and also political issues, maybe not to be political, but also to at least how architecture is impacting to other sites. So I think this is one suggestion to be interesting.
It's a very good suggestion, and I have to give you a replica. We try that in some countries, and sometimes it works, sometimes it doesn't, but it's clearly a good suggestion. For example, in Romania, where we come from, we had many events where the politicians or decision makers or people representing different professions and organizations were involved in the events, and we could talk with them and we could organize some separate discussions on specific issues. We all know because we live and work there. So, but when we are visiting a country, we need this kind of help of the host to understand much more what is needed there, what is the hot topic of the time, which are certainly different. But thank you for your suggestion, and maybe we'll talk in Istanbul, which, by the way, is one of my favorite cities in the world, and I think not only mine. So we can talk about that place, or we can talk about what are the problems there. What do you think?
I think well, I'm coming from the city which is on the Silk Road. And Tashkent is also on the Silk Road, and these both cities always were connected through that route. And I think this Silk Road were always useful to transfer knowledge and goods, right? So the shared architect geography in general very much replicates in terms of geography the countries.
I like that.
That's on a Silk Road, and it does the same. So it transfers knowledge. People meet each other, get news, and this is the most important thing, to meet people. And I spoke to Florin about Astana, and we are thinking. I agree with you on collaboration in different fields. We are thinking of why won't we do the narrow agenda on landscaping for Astana, because they did a good job recent years, and we can focus on landscape design and bring people from that field. So this is what we planning already through this connection of people, and this is the Silk Road of architects.
It's very nice how you
Catchy phrase.
You name it. Right, we are having 4 more minutes before the planned special lecture we are going to receive. So please be rough and tell me what to change. what to improve, because of course you had very good words because you felt good, and I'm happy for that, and you had good experience, but help me to understand more about the expectation, about what could be really improved in order to step on the next level, let's say.
Well, I think for the improvement side, as to add something, maybe it is a possibility because it's where all very valuable colleagues are gathering. It could be some opportunity for, because share is held in different cities, and maybe from this city and culture, maybe schools of architecture, the students can be more engaged through workshops. So this could be, because it is a good opportunity for them to catch up, and maybe it can be more specified through involving some production ideas, like because we are presenting, we are sharing ideas, but at the same time it could be some maybe alternative methods to as well to share and engage and more interact with the youngsters of the towns, so they can be at least more influenced with this movement as well.
We need the help of our academic partners. We
Yes.
did this here and there. We also had opportunities to take advantage of the fact that we have great speakers, and we move them into the schools of architecture to have a masterclass. For example, we did this in many places around the world, and it worked. But indeed, in terms of organization, I think Florin and his team, they need to take a break after this event, and to, I don't know, not to go to a sanatory or somewhere to recuperate mentally and physically or something like that. But it's quite a lot of organization behind which is needed. So I only see this through partnering and with the local help of the hosts. But thank you again. I think I also feel I'm teaching, and I feel the students are not here, so I'm not happy without them, and we shouldn't be. Thank you.
Thank you.
I think I completely agree with my colleague, but it would be extremely interesting, for example, to visit a production site or university and see what teaching looks like there. It could be like maybe an hour trip or something, and just choose one industrial company to be able to get and see it from the inside, if you have possibilities like this, or maybe see some architectural marvel that exists in that.
Just look around. We are inside the showroom.
This is fantastic.
One of the most important.
I'm really impressed with this, but I'm saying if this could be like also a possibility to integrate everybody here into experiencing something extraordinary, and it's usually very difficult, and there's never time to go to some production site and ask them to let you in. But if it would be like organized trip, and they could benefit from it, because we would learn how to design things better by learning as well.
Thank you. Well noted.
Yeah, I agree. So I think the good idea, what IT guys do, they do hackathons in 2 days. So 2 days hackathon for student architects, and you have like a bunch of experienced mentors. They can do teams, they can do a side event on creating some ideas.
It's quite popular.
The ideas can come from cities or geography that
like
share.
solving a particular problem.
Whatever issue the cities have. They can pitch the idea, and the teams can create the solution within 2 days, and then you do the competition and award just for these 2 days and 2 teams of brainstorming. I think this is like very exciting that can happen during 2 days. And I like the idea that's happening right now with jury and award and all these interesting projects all over the world. So this could be something that attracts the the event.
Thank you very much. You know, every good thing has an end, but after a good thing comes another good thing. So we shouldn't be upset of that. Thank you very much for your contributions. I'm trying to stay into the schedule. So,
thank you for inviting us to the stage.
So some applauses for my guests. Thank you very much, Magdalena. Thank you for your contribution. Burak, see you around.
See you in Istanbul.
Yeah, of course, of course. Okay, guys, so we are in front of the special guest lecture, and I have the great pleasure to invite on stage Spencer de Grey, who's a senior partner and head of design at Foster & Partners, which is an endeavor which I think doesn't need any kind of presentation. Yeah. Spencer, welcome and thank you very much on behalf of Share Architects for being here with us.
Great pleasure.
Yeah. So the floor is yours. Nobody's waiting after you, so be comfortable and share with us.
Does that mean I can go on all afternoon?
Exactly.
Well, it's an incredible pleasure and honor to be here today. I've only been here for 2 or 3 hours, but the atmosphere and the subject matters that are covered and the talks that are going on, I find very, very rewarding, very interesting. And I think it's very nice that Share have organized representations from such a wide, but a very, possibly a very wide area of the world. I'm going to talk about 10 projects, and let me start.
It's not working. Push the central button, the large one. Yeah. It's not working?
It doesn't seem to be. Oh, is it done?
Yeah.
It's all right, that's okay. I joined the office shortly after this photograph was taken back in 1971. I actually arrived in 73, so I've been in the office quite a long time. And I think this is a very important image, because right from the beginning when Norman set up the practice, he wasn't interested in just exercising the skill of architecture. He was very interested in the integration of architecture with structural engineering technology, with graphics, and in this case, the cost advisors. He felt that good design comes out of a total approach that incorporates everybody. A fully integrated design approach. And I think actually that is even more relevant today than it was back in the 70s. I think probably as a profession we are under some threat, and there are lots of other people like project managers who think they can do our business just as well and do it much cheaper. And I think to combat that, we need to be tough and strong, and in order to do that, I think we need the help of all the people who contribute to the design of a building. And as a practice, we have a wide range of skills. We like to think of ourselves as a sort of mini university, and I think we have something like nearly 200 different degree skills in the office. And everybody sits alongside other people. They're not necessarily divided by disciplines, and so there's a very easy flow and interaction between different skill sets. And I think that is continuing the tradition that Norman established right from the beginning. And you can see here a number of the skills that we have, the sort of atmosphere of making things in the office. We thought back in 1995 when computer-aided design took hold that we were never going to make another model. I think we make far more models today than we've ever made in our lives. We use models all the time, and they're extremely helpful. So this is the sort of creative atmosphere of the office. And in particular, within that office, the sort of primary skills, in addition to architecture, we have a very strong structural engineering team, a very strong environmental engineering team, together with urban design, furniture and product design, and very critically important, research. We have 3 or 4 different research departments within our office. And they interact with everybody in the office and play an important role in making certain that we are keeping abreast of what is happening in the outside world, bringing new ideas into the practice. And they, in turn, are supported by a wide range of other skills like model making and so forth. So it's quite a complex network of different abilities that we have. And just turning to the more particular, right from the beginning, as you'll see in just a minute, we have been interested in and very much have preached a sustainable approach to our work. I'm not very fond of the word sustainable. It means too many things to too many people and is, I think, quite a misleading word nowadays. I think the word responsible is actually a better, more all-encompassing word. So responsible design has been at the heart of what we've been doing for a long, long time, going right back to those early days. And I'll touch on that in just a minute. And we have developed a series of topics that basically emerge out of the United Nations sustainability strategy. And then we can take those, and you can see on this diagram, there are 10 of them, which are around the outsides of the circle, and then we can evaluate at different stages of a project how well a project is doing to achieve the goals that are set. And you can see here, I think this is the new airport in Warsaw in Poland that we're currently working on. And each topic is subdivided into subsets, and then you can see, depending on the length of the color, how well at a particular time we're achieving that topic. So we have a quite comprehensive auditing scheme for design, sustainable design. And I'm going to talk about 5 of those topics today, related in each case to two buildings. One contemporary and one that took place a little while ago, and the lessons learned from that. So if we start with community impact as one of those criteria, these are 2 buildings, both museums, one in the south of France, Narbonne in Narbonne, almost on the Spanish border, and the second is the University of East Anglia, the Sainsbury Centre, which was built a while ago. But as you can see from these 2 photographs, they have things in common, and in particular in these 2 photographs, the height of the spaces, which is very important in terms of flexibility, which is another key criteria. The height of the buildings is around 7 to 8 meters in each case, which gives the users of the building a great deal of freedom about how things are displayed and so on. Narbovia was completed during the pandemic and is basically a single-story, 7-meter high space, which is a museum for Roman antiquities. Narbonne was one of the most important towns in the Roman Empire. I think it was almost the biggest town outside of Italy. And it was a key port on the Mediterranean. It was very thriving and a focal point. And of course, people died in Narbonne, like they do anywhere else. And in the 19th century, as you can see here, the stones, the funerary stones, which were built along each of the roads running out of Narbonne, had been used in medieval times to build the city walls, which you can see on the left. And in the 19th century, the arrival of railways destroyed the city walls, and somebody with great foresight stored 900 of the funerary stones and put them into a church in the middle of the town, where they stayed until they moved to our new museum. And before they moved, they were restored and then moved into what we call the lapidary wall, which is the image on the right. And here is the lapidary wall. As I said, it's 7 meters high and 70 meters long and has 900 stones. And we thought this was a very strong and quite dramatic way of displaying stones which individually are interesting, but become even more interesting when arranged in relationship to each other. And we rushed off to IKEA, metaphorically, and thought that industrial warehouse racking system was a very good way of displaying the stones, as you can see here. What you can't see here is that behind the stones there is a moving gantry that allows the archaeologists working in the museum the ability to take a stone off its position and study it in the laboratories behind. So it's not about only public display, it's also about research and development. And the AV system that we have, the display system, tells you the history of each of the stones. That's halfway through its production. And then you can see how that stone wall influences and can be seen from other parts of the museum. This is the full-time permanent collection. And in the research areas, there are courtyards which are bringing light and sunlight into the research laboratories. And then the appearance of the building, it's built in a very special concrete in layers of locally colored concrete to create quite a warm background for the exhibits, both internally and externally. And you can see that constant height of the building, which gives you great flexibility in the future. And those themes actually tie back to the Sainsbury Centre, built in the 70s. It's a very different building, but the themes that run through the work of the practice, I think, are very important. And so you can see here the structural form, a thick structural wall, lightweight wall, which has all the servicing and the lavatories and the things that make the building work, the plant, and then creating a very generous 7-meter high space with total flexibility about how you display the collection. And the collection is the collection of the Sainsbury family, and is an amazingly diverse and interesting set of work. And they wanted it to be like their living room. And you can see here the way in which the air handling plant is displayed actually in the depth of that external wall. And this is the impact of the space. Again, not a traditional museum. It's carpeted, it's very quiet, it's a place of reflection as well as of study and enjoyment. And they felt it should be like their own living room. Now moving on to the next topic. Here is a building that we've recently completed in Madrid. It's an office building for Acciona, the energy company in Spain. And I shall compare it to some work, studies that we did back again in the 70s. So this was a building not in the center of Madrid, but on the edge of Madrid, which was in danger of demolition. It was in bad repair, and the general view was it should go. But Acciona had the intelligence and enthusiasm to keep the building, which we then restored to make contemporary office space. And this is the cross-section through the historic building and the way it links out into the surrounding space, which also belongs to Acciona, which we turned into a landscaped 12,000 square meter park for the community and for Acciona. And underneath that is car parking hidden away, so that all the floors in the existing building are utilized, and the lowest floor breaks out into a terrace. And then within this restored brick envelope, we insert a timber structure, which is obviously very ecological in its content and its makeup. And that is timber that has been resourced locally and manufactured locally. So again, cutting down travel distances for the building material to create a language of timber construction to support the floors for the extent of the offices. And those ideas about the use of materials and the ecology of the building and the construction goes back to a project we did. It never was realized, for Fred Olsen, the ferry manager, who had a very good operation to the Canary Islands. Gomera was rather isolated, but he decided to incorporate that into his ferry service from Western Europe. And the threat of that was it would end up where the no entry sign is showing. It would end up being a development that was just a ring of buildings, ill-considered, around the edge of the site. And we felt there was a different way of tackling that, and to try and bring life to the whole of the island and an experience that made sense. And we then developed the idea of a central park in the middle of the island with radial routes out, so that one tried to preserve as much of the edge of the waterfront as possible. And then using different technologies that were very much in their infancy in those days, the wind power, water pumps, and particularly solar energy, to make it a self-sustainable development. So you can see here the comparison between the traditional local residential unit, and then the ability, and of course this was way before photovoltaic or any of the more recent developments in terms of energy generation, using solar to heat the water, and other techniques that were going to make each of these individual buildings a sustainable solution. Moving on then to the whole world of offices and headquarters, and to look at Bloomberg in the centre of London, which was completed a few years ago, and comparing it to other high-rise, two other office buildings. And all three of these buildings explore the use of natural ventilation in deep plan buildings. So this is the outside of Bloomberg. It's on the old Roman road, one of the old Roman roads in the city of London, and the arcade that goes away from you in the middle of the picture is actually the line of the original Roman road, which we celebrate as part of the scheme. The scheme is 2 buildings on a very large site. And these buildings are about 8 stories high, very much in keeping with their surroundings. And then you can see that Roman route going through the 2 buildings and stretching on the existing streets on the other side of the road. So it was very much a response to the original historic context. And then at the heart of the building and part of the whole ventilation system is a ramp that connects all the floors, and that's a sort of social interaction space. And you can see here the way in which the fresh air comes in from the outside. It is then it moves across the spaces, the workspaces, into the central atrium and up out through the roof. And in this way, we get a very efficient and I think very successful naturally ventilated building. And on the bottom right, you can see that the fins on the outside integrate the vents for the natural ventilation system. And this is the ramp, which is a quite spectacular space. And as I say, it's a deep plan building. And then in Bloomberg style, they like everybody who comes to the building to arrive at a particular floor, which is called the pantry, where people can wait for meetings, where they can have meetings, where they can have snacks and drinks throughout the day. And this is at the heart of the building. And then you can see in the ceiling a very carefully designed, integrated acoustic lighting and air supply, not air supply, heating and cooling coils integrated into the ceiling system. And that interest in natural ventilation first started with the Commerzbank back in the 90s, where the then highest building in Europe, every single office was naturally ventilated. And the diagram in the middle shows the way in which fresh air was introduced into the 9 gardens, which you can see on the right. And then the inward-looking offices had their fresh air from the gardens. The outward-looking offices had their air from outside. And we predicted that they could use that fresh air for about 60% of the year because it was going to be too cold, too hot, or too windy for the opening window system to allow it to be used on those days. They had such a good project manager in the building, the facilities manager, that he got it from 60% to 85%. And likewise, that meant that the backup system, which was sort of the minimum ventilation and the radiant heating and cooling, only had to operate for 15%. So that saved a lot of energy. So it's been a highly successful and efficient solution. And that thinking about natural ventilation went on to a historic building in the centre of London. This is His Majesty's Treasury. This is the headquarters of the financial system in the country, which was built in 1916, and it's the same area as the previous building, the Commerzbank, but it's laid on its side, and it has, in a similar way, a lot of courtyards, many more than the Commerzbank. And of course, in those days, the courtyards in a deep plan brought light and ventilation to all the offices. And then it had 3 major courtyards, which were grossly underused. So when we stood back and looked at this building, we realized that if we covered the little courtyards we could use those as chimneys, ventilation chimneys, that took the air from the offices on either side and extracted, not extracted, but the air then moved up and dissipated at the top. And it was really extraordinary because this is just traditional sash windows moving up and down. There's nothing more to it than that. And we went to visit it again a couple of years ago on a very hot day, and we were terrified that we were going to be showered with rotten tomatoes because it didn't work. It works incredibly well, and we've never had a complaint. So it's a very basic system that is actually very successful. So ventilation, if it's engineered properly, can be achieved with a lot of buildings. And you can see here those courtyards are used for places to eat, to study. They provide all the support areas in the building. And the big courtyards were, as you can see on the left, deeply depressing. And on the right, with Catherine Gustafsson, we transformed the two rectangular gardens into proper gardens. And they're used very much, particularly in the summer. And then moving on to two urban projects, and the importance of connectivity. The first is Slussen in Stockholm, which is still yet to be completed, and goes back again to looking at what we learnt when we did the Corridor in Nîmes. So on Slussen, you can see that in 1935 on the left, the then king decided that the car was by far and away the most important thing on earth. And he built this sort of memorial, perhaps that's not quite the right word, but to the car, and a huge sort of traffic interchange in a very sensitive site, but that's in the middle of Stockholm, and was the site where, and still is, the fresh water is separated from the seawater. So it has a great symbolic significance in the city. And that started to decay, and we proposed a new approach where we opened up all the water to the public. We created a lot of public new space, and we limited the amount of space for the cars to the minimum required in the 21st century. And here is the state of the concrete in the 90s. I mean, it was the most abysmal undercroft, very dangerous and very unpleasant. And as part of the project, it's also a transport interchange. We've built a very large bus station carved out of the granite, and the picture on the left is the original visualization, and the picture on the right is taken a few weeks ago. And is nearly finished. And this is a very large bus station. It's the key bus station in Stockholm. And then above that and around that, you have the new public spaces on the waterfront, and then stairs going up to a new civic space at the head of the stairs. As probably people who know Stockholm, the granite cliffs are very impressive. And we picked up the theme of the granite as the way of creating solid walls into which these triangulated pavilions are inserted, which are going to be, next year, will be restaurants and cafes for the people of Stockholm. And this image shows you what that looks at the lower level, and the lock that separates the two waters is on the right-hand side. So it's a very important piece of flood defense, both for Stockholm and the surrounding areas behind Stockholm. And then when we were awarded we won the competition for our museum and library in Nîmes, the new mayor saw this as being one of two initiatives to recreate Nîmes as a city. and he commissioned Jean Nouvel to do housing and us to do the museum. And you can see on the left the image that shows the original opera house that was there that burnt down in the 30s and was demolished more recently before we started work on, obviously, on the site. And the square in which I think the most perfectly preserved Roman temple sits was just covered with cars, and it was isolated and miserable. So the project for the new corridor was not only about the building, which I'm not going to talk about, but was the surrounding areas and providing a suitable setting for the Roman temple. So on the left is the sort of car parking that was on the Opera House site and on the temple site. And that now has been totally transformed and has become the sort of outdoor space, civic space for the town. But very importantly, when you see that site in context, it's on the route that links the arena, the Roman arena, which is a fabulous Roman building at the top left, with the very, very beautiful 18th century water gardens on the bottom right-hand corner. And we actually created a diagonal route through our building, which goes past the place where you can read newspapers, that links the two. And we completely redesigned the square itself, and that activity and the quality of the landscape has then stretched from the building and from the square across into the rest of the centre of Nîmes. And if you haven't been to Nîmes, I really recommend it, because the quality of the urban design is absolutely amazing. They've taken such care with it. And then to talk about the last project, this is looking at the new airport in Phnom Penh in Cambodia, which opened a few days ago, and the work that we did at Stansted some time ago. And so this is the new airport, and it's the lightest in terms of weight airport that we have designed. It's very economical structurally, and it provides great flexibility. And it has then two arched extensions, which are the piers from which you go onto the aircraft. And you can see here some of the studies that we did for the structure. It's on a 36-meter grid. It's an arched domed structure, which is structurally very, very efficient. But we were also very interested in the local techniques, the crafts that exist in Cambodia. And I'll come back to that in just a second, but you can see here the structural form as it was halfway through the construction compared to the opening ceremony and the use of the airport today. And of course, in this part of the world, sunlight is not your friend, it's your enemy. So the top light, the natural light, is very carefully veiled with different layers of shading. And we looked at the way in which, in that part of the world, the use of basketware, the way in which the basketware, the threads were woven, and used that as a reference point for the internal linings of the airport. And so this is the end result. And what is quite extraordinary in terms of flexibility, it's no longer just an airport. It has a very large Buddha, which was part of the design, in the center, and it's almost become a temple. People come here not to get on an airplane, but to pray in front of the Buddha. So it's already showing its flexibility and adaptability. And looking back to Stansted, you can see here the form of that. The grid is the same, the structure is different. And you can see here how important that flexibility, if you organize the structure and the services, the ability to change. And on the left, when the building opened, there was only one shop in the whole terminal for 15 million passengers. And on the right is a photograph taken fairly recently, which shows it's been able to accommodate a massive change in terms of the density of and extent of the shopping. But perhaps even more importantly, and it helps the flexibility and the long lifeness of the building, is when we were commissioned, the traditional terminal at London Airport had all the services on the roof, a heavy structure to support them, and then obviously service distribution at the ceiling level, very traditional. We literally turned that upside down, and we freed up the roof just to let light in and keep the water out, and all the services are below the concourse floor, and you can just see the dark grey service pod in the structure, which brings the air and all the information systems up onto the concourse level. And this is not today. This was taken originally back in the 80s, 90s. You can see the way in which the natural light it provides more than enough illumination during the day for there not to have to be electric lighting in the concourse until the evening. And of course that was very energy efficient, and it provided a very strong basis for the cost control that we had to exert on the project. So I think there's a lot to be learnt from previous studies, previous buildings. I don't think you can ignore them as architects. They re-emerge in different forms. They're part of the bloodstream of the practice. And I hope I've shown that many of these projects, if not all, have a strong, responsible approach to design. Thank you very much.
Thank you very much for this solid piece of contemporary history of architecture you presented. I enjoyed very much the dialogue between the pairs of works. Do you agree to join me for a very short conversation?
Yes.
Yes, please have a sit if you like. And I take advantage of your presence here. And just to remind you, we invited here a lot of architectural practices from which have something in common. They all come from this part of the world, which was, I would say, on the wrong side of the Iron Curtain some time ago. And okay, that's history again. And most of them are young, and that's very good. And most of them are competing and trying to produce the best architecture they could. So I would like to challenge you to give them an advice.
Stay young.
That's a good one. All right, and
I think it's really important. I think we're very lucky because there are quite a lot of us. I think our average age is just over 30, and I think if you're going to maintain enthusiasm for design, for architecture, for the planet, it's incredibly important that you don't get old. Because older people are wonderful, but they can become set in their ways. So we very much, well, we have a lot of students obviously in the practice, and they come between parts 1 and 2, and then after part 2 they come back. And I think we've always encouraged young people in the practice. And it's very interesting when we do employ older, more qualified people, I think we're a perfectly normal practice, but they find it quite difficult to fit in. And actually, the people who've been successful in the practice are people who've arrived young. Mm-hmm. And the injection of youth and keeping that flowing, I think, is very, very important. And I think if you don't, there's a danger that the practice slowly ossifies and becomes out of date and everything else. But the other thing, of course, is the young people bring is an incredible enthusiasm, and that's very infectious. So I think being young in an architectural practice is a great opportunity, and you should exploit it for all your worth, and make your impact and influence things, because you represent the future as young people, and architecture plays an important role in that. And I think it's very important that the young people do exert their influence and are listened to. Otherwise, again, we just dry up.
Mm-hmm. How can you stay young as an architect?
I think by wanting to explore, to be inquisitive, and obviously you're more energetic when you're younger than when you're older, to use that energy in a creative and a constructive way. And I think by doing that, I mean, this is probably hocus pocus, but I think you do remain younger in spirit. Mm-hmm. If you, I mean, I know a lot of people who say, oh, I'm old, and you sort of feel they've packed up. Mm-hmm. And I think that's deeply depressing. I think you should be as enthusiastic at the age of 80 as you are at the age of 20. I think it's very important.
It certainly is. But how do you combine wisdom with youth? Because obviously you do that in your practice.
Yes, I think that's a very good question. I think you can't preach.
Can you please speak?
Sorry,
yeah.
You can't preach. You have to be light of touch. And I think it's quite difficult as you grow older how you offer your wisdom or your thoughts or your philosophies, how you make them digestible for people who are younger. I think that's quite a challenge. And I think if you start preaching, you're done for. I mean, if it, you've got to do it my way because I know how to do it. That is a recipe for disaster, I think.
Certainly. All right. So, look, the practices of architecture are so different.
Yes.
In terms of size, of composition. You started by a slide which was presenting many type of specialists of professions engage in the same process. So there are practices which are quite large and have continuity as yours.
Yes.
1967. Well, most of the people in the room were not born at the time. And practices which are keeping this dimension of which is very personal, or a small team,
yes.
which is again like a family in a way. And they're all doing architecture.
Yes.
What can you tell for the small practices? And how do you see them, and what's their role, and how can they evolve without having these amazing resources you created, like research departments, and you mentioned?
No, that's a good question. I think we've tried, and I was illustrating that, we've tried through the years to retain the sort of fundamentals of what were there at the beginning. Mm-hmm. That's not to say that we're not rather different now, but I think the sort of thought process and the sort of interests and the basic principles of the practice have remained pretty constant. And I think those fundamental approaches are common to a small practice like it was when I first arrived. It was about 30 people. A smallish practice. Mm-hmm. as it is for a bigger practice. So it's a bit of a challenge for setting the right principles at the beginning, because if they don't survive, you've then got to sort of reinvent the wheel. But I think our interests still remain faithful to, not necessarily all, but many of the ideas that when Norman was talking to Buckminster Fuller, we were exploring in those days.
Yeah. Would you agree to take some questions from
yes, of course, very
from
happy.
the audience? So I challenge you, dear friends, to take advantage of this presence here and ask some questions. Sorry?
So I take the chance to make.
It works, I think. It works. Take this one.
I take the chance, since we have a larger audience, to ask you the same thing I've asked you this morning, because I find it interesting how you answered about technology, about the technologies that you were labeled 30 years ago. And the fact that I stayed 30 years with the same question in mind, and today I can express it and ask it to you. Why 30 years ago Jonathan Glimsey defined Norman Foster as a techno-lord?
That's a question that is very interesting to explore. I think that perhaps belongs to an era where every architectural practice was given a label. And of course there was a label called high tech. I think, and I hope I've demonstrated it today, that it's incredibly important to take the technological topics that make up a building, the structure, the services, and so on, very seriously. And as that picture of Norman showed, to integrate those skills which are a vital part of any building, be it a small house or a factory or a large office, whatever, to integrate the services, the structure, and the technical side of the building. If you don't do that, you end up with collisions and a mess. And I think we all feel very strongly that that integration is at the core, is not the only thing, obviously, but is one of the things that matters. But it is not at the expense of the community, the people who use the building. People come first and foremost, absolutely critical point. And the technology is there to support. It's not a celebration in its own right. It's to support the endeavors that one makes to design building for people. And if I look at the building that we did, a concert hall in the north of England, in one of the poorest communities in the country, the radical transformation that that building has had, and we know, we get feedback all the time from the community there, you know, is amazing. And I think, as a practice, people do come first. And I think the word high-tech is very misleading because it implies that technology is the be-all and end-all of the building. And I promise you that is not what we do. But we do integrate the technology. So as you saw in the illustration of the airport in Cambodia, it ends up looking beautiful as an interior, not like the 70s terminal building at Heathrow, which was a maze of ductwork and other services. So I believe very strongly that that integration is very important, but it is in no way at the expense of the human experience.
Thank you, Davide. Anybody else, please? Yeah, was it?
Thank you. Yeah, thank you. Coming from academic background, of course you have this multidiscipline team within your firm, but what about recruiting young architects? Are you identifying that the gap between the academia and the practice in line of this fast innovation cycles that happening in the practice? Is this gap extending between what's happening behind the wall of faculties and the practice requirements of know-how and capacity?
It's not working. I'm giving you this one. Or it's started, so maybe the battery is gone. We are at the end of the...
The research that we do in the practice is both integrated into the work that we do, which is building buildings, but is also, they have their own projects. And it's a very small team, for instance, that have explored with NASA in the States, living on the moon and living on Mars. I mean, that's a tiny group of 2 or 3 people within one of the sort of research groups, and that is a sort of self-contained project. But I think it has a very important aspect in generating enthusiasm and interest and keeping people's minds broader rather than shallower. And therefore, although, you know, we haven't got teams and teams of people designing housing for the moon or Mars, the fact that we're doing that work is an inspiration to the whole practice. And I think that's a very important factor. So there are certain, I mean, we're big enough to attract different kinds of projects, and to be able to take on some of those projects and use those both as gaining knowledge that might be applicable or is applicable to everything else that we do, but also acts as a focal point for enthusiasm and keeping one's mind open and so on. I think they're very valuable for that. And funnily enough, the work that we've done on the sort of space habitation has attracted more excitement and interest almost than anything else. I mean, people look forward to the next installment. So I do think that, you know, within a practice, even if it's just one person working on something that is out of the ordinary and not directly applicable, I think that sort of work is very valuable to the morale and well-being of a practice and the learning of the practice, because you can never stay still. You have to learn, and I think that's very exciting for us. We really enjoy that. I don't know whether that answers your question.
Thank you. And maybe a last one.
Thank you. I've got a question about leading your team, if I may. When leading your team, how do you foster an environment that supports experimentation while still maintaining the discipline required for high-precision design work?
It's interesting, and it goes back to talking about young people. I think without exception, all the leaders, the team leaders in the practice came as students or just after they qualified to join the office. And I think what that does is it maintains the sort of continuity of the thought process. And I think also there is no substitute as a member of the office seeing somebody who's risen up and become a leader of one of the teams. Because if he can do it or she can do it, I can do it too. And I think the fact that we don't import, as it were, as I was saying earlier, external, more qualified people very much of the time gives everybody the opportunity of thinking they can become a leader in the future. And I think that leadership has been through the thought process and the philosophy of the practice from day one, and so is very much part of the practice. But I think it's also very important that the other side of the coin is how do you ensure that people who are leading design in the practice also don't get ossified and become set in their ways. And I think that's again where the younger people in the practice are so important, because they challenge. They're not fools. They're incredibly intelligent, and they challenge in a nice way, not in an unpleasant way, but they challenge all the time the thought process of the elder people, and I think that's unbelievably valuable. I may not have answered your question precisely. I hope that's helpful.
Yeah, I noticed. Thank you so much anyways. It's been an honor.
Thank you.
Thank you very much for your questions. Spencer, thank you very much from the depth of my heart of sharing this with us.
Very nice to meet you.
Guys, we meet.
What you're doing by coming together once a year.
Please use the mic for the...
Sorry. What you're doing coming together once a year, I think is unbelievably important. Places like America, can rule the ways, and I think it's terrific that this represented here, the group of countries, is really impressive. And I wish you all the best.
Thank you for that. Thank you very much. Spencer the Great. Are you staying tonight for the gala? Yes. So we'll see each other later on.
Yes.
Thank you very much again. We break here. We have all the reasons to break here. And see you tonight.
Yeah, I imagine.